Namaste, welcome to Stitapragna YouTube channel. You are watching AWS Data Engineer Associate Exam Study Guide. So far, we have uploaded three study guides, two AWS study guides, and one Snowflake exam study guide. And so far, whoever are watching those exam guides, they are able to pass the exam successfully. You can check the comments for yourself. And this is the fourth installation of this playlist where I'm going to upload more study guides coming days. The next one being the AI Foundation, AWS, of course, following with Machine Learning Associate and other exams. Since you are here wanting to write the Data Engineer Associate certification exam, I want to make sure that this video is designed or created or uploaded specifically to help you with your certification exam. That's it. This video is not um, meant for teaching you data engineer associate or data engineer specific topics. That is not the intent of this video. I have to make that clear. If you want to pass the data engineer associate exam successfully, then watch this video. If you want to learn data engineer concepts, not concepts but tools on AWS and the projects, then I would recommend you to watch another playlist that is on our YouTube channel, which is the AWS Cloud Real Time Projects playlist. Okay, this is the playlist where we have 100 real time projects, and you can do the hands on as well, but you need to enroll into AWS Cloud Quest. It is a service offered by AWS themselves, and all the projects that we do here are actually implemented by AWS real time for different companies. I would recommend you to check all the projects, and if possible, I would recommend you to enroll into this and do all the projects. You can find the details of how to enroll and etc. in the first video. But if you are only interested in data engineering, then you have them here as well. So scroll down, starting from project 25, they are data analytics or data engineering projects that you would do as a data engineer. If you know got a job as a data engineer in a company, you would do projects similar to that. Or if you are instead planning to learn the data engineering core concepts and maybe enhance or upskill using Spark, then this is our awesome playlist that is currently getting recorded. So far, we have three chapters. If you want to be an awesome data engineer, maybe in the next 6 months, then I would recommend you to start your journey watching this playlist. Okay, this playlist is the beginner's course. Once we finish uploading all the videos for this, we will have an intermediate course and the advanced. What is the difference? Well, in the beginners, I will introduce you to the world of data engineer. I will introduce you to the world of Spark, and I will introduce in how many different ways you can actually code Spark. Okay, one is using Python, two Scala, three Java, four R. I am going to show you examples of each of these programming language, and I don't want you to stick to one language. You can watch more details once you start the playlist. But the point I am trying to make is beginners, you will have all that. Check the videos so far we have uploaded. In the intermediate, we will have Spark streaming plus Spark code deployment, Spark tuning, whatnot. In the advanced, we are going to have machine learning and GraphQL, all that awesome stuff. So if you're interested, follow this playlist. And along with this, what I want you guys to be aware of is this website. Why? Because if you might have seen in the title that there is a cheat sheet that you can download. So in order to do that, you can come here and click on the cheat sheets, or you can go to courses, AWS, and here cheat sheets. Once you go here, so far I have uploaded 4. I will upload more. So this is Data Engineer Associate. So click on that, and you will have a small cheat sheet guide here, which you can download, print completely free. I would recommend you to go through the cheat sheet maybe a day before the exam. Don't use just this to write the exam. That would be a bad idea. Um, but there is some amazing thing in case if you are interested in that Spark course. Each of the Spark episode contains quiz where you need to answer MCQs that you learned, the concepts that you learned in that particular video or episode, and then it follows with an interview questions. And the craziest part is all the code that I show in those videos, I have them here, just for the sake of it. In case if some people maybe want to refer to the code that is covered in the video after watching the video, you can come here and you can look at all the code. And the next most awesome part is the homework exercises. I'm going to give you the worded exercise, then you have to write your code on your own. Of course, I'm going to give the solution, but that's not the point of giving you homeworks, right? You do it on your own, then compare it with my solution. That's how it works. So there is amazing content going to come on this website. Go check it out. Again, everything is free. Now, let's jump into our exam study guide. The way that I formatted this entire video is you are going to see scenarios instead of MCQs, and each scenario is going to have two slides. The first slide will show you the scenario. I want you to read the scenario, then pause the video. Based on what you know, I want you to answer it. If you have pen, if you can pick pen and paper and write the answer, that would really be awesome. But try it. Even if you don't know, just try to guess. I mean, you are here trying to write the exam. Okay, so I want you to do that. And once you do that, in the second slide, I'm going to show you solution, and I will give you a brief explanation why that is the right solution. And I will show you some key points which I recommend you to pause the video and read them. So that's how it is going to go. And I don't want you to use this video alone. You can definitely use it and pass the exam successfully, but that is not my intent. My intent was for you to use this video maybe 3 days before the exam. Okay, you already watched some courses which I don't recommend. Instead, I would recommend you to go to the AWS documentation page and go through all the documentation and white papers. Right, these days everybody has access to chat GPT, so you can copy paste the notes from these documentation and ask ChatGPT to give a summary, which is what the Udemy courses or other courses is going to show you. Whatever course you are going to go through, that will be the content, of course, was there in the documentation. So use ChatGPT or any Gemini or any GPT. It's a combination of the white papers and documentation. If you don't have time, go for the Udemy or any course. The reason I want you to go to the documentation, and that is sometimes you will have more stuff covered and up to date stuff. And another thing is when you do by yourself, you will learn more than if somebody else did something for you. So, anyways, coming back to this video, uh, I want you to use this as a review maybe 3-4 days before the exam instead of using this solely for the exam. You can use it. There is nobody is stopping from you. You can use this, go through this video, you will pass the exam, but my point is not that. That being said, let's jump into scenario number one. A data engineer is running glue job inside a VPC. Pull files from S3 bucket. The job fails with an error related to the VPC gateway endpoint. All right. So how do you solve this problem? How do you fix AWS Glue S3 connection failure? The solution to this is You will verify that the VPC's route table includes inbound and outbound routes for the S3 VPC gateway endpoint. Remember, AWS glue jobs running in private subnets, they access S3 through VPC gateway endpoint. That was mentioned in the question. They are trying to access S3 VPC gateway endpoint, correct? If the route table doesn't include proper routes for the endpoint, then glue cannot reach S3 even if IAM permissions are correct. Adding the endpoint routes enables private network communication without using public internet. So whenever VPC or any gateway endpoint is not gateway, VPC endpoint is involved, make sure that the routes are configured properly. A data engineer manages a customer data lake in S3 used by analysts across multiple countries. The governance team requires that analysts only access customer data from their own country. If the analyst is from India, they should only be able to access customers' data. We all know, right? Most of the governments don't want that country's data leave their country, so that's why the data they use the local data center to store their data. So, but we need to implement this. If you give S3 bucket access, you already know that if somebody has access to that bucket, they can access all the data, not just the country's data. How are you going to implement that? Well, that's where AWS Lake Formation comes into. AWS Lake Formation provides centralized governance over data stored in S3. Its row level security allows dynamic filtering of data per user or group, ensuring that analysts see only their region's records without needing multiple data sets or complex IAM setups. A data engineer at a media company is tasked with enhancing a content recommendation system. To improve personalization, the engineer needs to integrate third-party data sets into the company's existing analytics platform. But they want to minimize development time and maintenance effort. So what does this mean? Anytime they ask minimize development time, they are telling you to use either a serverless service or a fully managed service, which means any AWS fully managed service. Of course, even for this situation, we will have one, and that is nothing but AWS Data Exchange. If you are Snowflake, you might have heard about the same name, Data Exchange, right? This provides a secure and managed way to subscribe to and consume third party data sets directly within AWS. It eliminates the need for building and maintaining custom ingestion pipelines, letting data engineers access shared data quickly through APIs or S3 integration with minimal operational overhead because you don't have to set up any servers. A data engineer at a financial company is implementing a data mesh architecture to decentralize data ownership while keeping centralized governance. The engineer must ensure each domain can manage its data independently, but comply with company wide access and security policies. How can we do that? Well, we will use S3 for data storage. So, where in a data mesh setup, S3 serves as the common data lake for storing domain data sets, while Athena allows each domain to query its data serverlessly. Then you have the AWS Lake Formation, which enforces governance, permissions, and auditing across your domains, integrating with AWS Glue for catalog management and ETL processing. This combination It provides scalability and security with minimal admin effort. A data engineer maintains multiple AWS Lambda functions that rely on the same custom Python scripts for data formatting. Each time the engineer updates the scripts, they must manually redeploy every Lambda function, which is a repetitive and error prone process. Correct? So, how do you avoid that? Or which solution you can use to overcome that? By using Lambda layers. These let data engineers centrally manage and version shared code such as utility functions or libraries. By storing the Python scripts in a Lambda layer, updates can be deployed once and automatically used by all functions referencing that layer version. This approach greatly reduces maintenance and ensures consistency across multiple Lambda functions. Um, we use Lambda layers extensively at my work. Some of the examples include if you were to connect to SQL Server database, we have several Lambda functions that connect to SQL Server. So we don't want to add the same libraries in each Lambda function, right? So instead, we create a layer that contains all the binaries that are required for that, and then we use that in each of our Lambda function. And whenever we had to update the Python version, we just do the change once and then re-upload the Lambda layer with a new version. And of course, you have to come back and update other Lambdas, but you don't have to uh, update the code inside the Lambda functions. That is advantage. Not just for SQL Server, we use a layer which contains pandas, which contains other useful libraries bundled together. A data engineer builds an AWS Glue ETL pipeline to extract data from Microsoft SQL Server, then transform it and load it into S3. The process must include a crawler step and run in a controlled sequence, but the engineer wants to minimize cost and complexity. How can we do that? AWS Glue workflows, they allow chaining of multiple glue jobs, crawlers, and triggers into a single orchestrated data pipeline. It supports conditional execution and logging without requiring external orchestration tools like step functions or Airflow, making it the most cost effective choice for native glue based pipelines. That is very important. Glue based pipelines, not if you want to integrate some other service into this. A data engineer at a financial services company needs to enable real time queries against Amazon Redshift data for a web based trading application. The goal is to allow the application to run SQL queries directly on Redshift without managing database connections or infrastructure complexity. That's where we will use Redshift Data API. This provides a simple HTTPS endpoint that allows applications to run SQL queries on Redshift without persistent JDBC or ODBC connections. It's fully managed, serverless, and ideal for web and mobile applications that require real time query access without connection pooling or driver management. A data engineer manages multiple Athena query use cases that share the same AWS account. The engineer must isolate query permissions, query history, and billing between different users, teams, and applications with minimal complexity. That's where we will use Athena work groups. This allows data engineers to separate users, teams, or applications logically. Each work group maintains its own query history, output location, and usage metrics. Using tags and IAM policies ensures fine-grained access control and cost tracking for each work group, simplifying governance within a shared account. A data engineer must schedule a daily AWS Glue workflow that runs several ETL jobs, and the jobs don't need to start or finish at a specific time. But the engineer wants to minimize cost for the recurring workload. Which option will you use? There is something called flex execution. In Glue, offers a lower cost option for non-urgent workloads. It optimizes compute allocation by using spare capacity within AWS, which may result in slightly longer start times. Since the jobs don't require strict timing, flex execution is the most economical way to run daily Glue jobs. Again, remember this is can be used for non-urgent ETL jobs, maybe non-prod jobs, I would say. The data engineer needs to automate data conversion whenever a user uploads a CSV file into S3. The Lambda function should trigger automatically and convert the file to Parquet format with minimal manual setup, or maybe no manual setup, that would be preferred. That's where S3 event notifications comes into picture, which can automatically trigger Lambda functions when new files are uploaded. By filtering on the CSV suffix, only relevant uploads invoke the conversion process. This serverless approach requires no extra infrastructure and scales automatically, minimizing operational overhead. To add more to this, I mean, even it's as a best practice, and even we do it at our work. So we have the S3 events, they will come and sit in SQS, and then we will have our Lambda trigger by this. Why SQS? Because there is a limit on how many parallel invocations that you can do for a Lambda. So we get hundreds of files in parallel at the same time. So lambdas that many cannot be triggered. You will sometimes lose some of these events. So in order to avoid that, you will use queue. What this does is it buffers these events, right? It puts them in queue, and depending on what is your parallelism that you set up here, the number of executions in parallel, it will send that many messages to the lambda, and then it will execute those lambdas that many times, whatever number. So this is the best practice. And again, um, sometimes what happens is you don't want to use SQS. You might be asking why. Well, SQS, there can be only one consumer, right? If you want multiple people to receive the same notifications, then they actually use SNS. Then you will connect that with SQS, because SNS can have any number of subscribers. So if same event needs to be gone to multiple people, then you will use SNS, then SQS. So data engineer notices that Athena queries are taking too long to complete. The query data is stored in uncompressed CSV format, and most users filter on a specific column when running queries. The engineer needs to optimize both storage and query performance without changing the underlying schema. How can he do that? This is a common question you will see. Remember, anytime if they say CSV data, just change it to Parquet. Parquet is faster because it is a columnar storage format that allows Athena to scan only the specific columns required by a query instead of reading entire rows. If it is CSV, then it will read the entire row and then it will give you the one column that you want. But if it is Parquet, it doesn't read the row, it only reads the column that you want. When combined this with snappy compression, it significantly reduces both data scanned and storage cost, improving performance and efficiency. This is true. A data engineer collects continuous sensor data from factory equipment using Kinesis data streams. The company wants to visualize real-time operational metrics on a large display, minimizing latency between data collection and visualization. Then you are going to use Amazon managed service for Apache Flink to process the streaming data, which enables real time. Also, low latency stream processing directly from Kinesis. By connecting Flink to Amazon time stream, the engineer can store time series metrics efficiently and visualize them in near real time through Grafana. Dashboards, an ideal setup for live factory monitoring. A data engineer manages daily financial performance records stored as CSV files in S3. The engineer needs the new data to be automatically crawled and registered in the Glue data catalog every day for query access via Athena and ETL jobs. How can you do that? How do you implement this? Well, the AWS Glue service role, it grants the necessary permissions for the crawler to read data from S3 and update the data catalog. Scheduling the crawler ensures that each day's data is discovered, schema inferred, and made queryable without manual intervention. The defined database organizes the crawled metadata for consistent access. This is a, how do I put it? The de facto setup. If you have S3 files and if you want to query, yes, you will query them from Athena. You can query them from Athena using SQL. But how do you create those tables? What if the schema of the S3 files changes? So even we have the same situation. So what you do is you crawl the files on S3, you will schedule them so that if there is a schema change, it will automatically crawl through the file, then will infer the new schema, and then it will update the table in the catalog. And then using Athena, you will create a database on top of this Glue catalog. And then you will start querying the tables from Athena using the data catalog table. It's as simple as that. This is de facto. Everyone does it. A data engineer needs to track daily table load statuses in Redshift and store them in DynamoDB. After each Redshift load job, the status, which is the success or failure, should automatically logged to DynamoDB for auditing and visibility. Well, you will use the same thing, Redshift Data API, which allows programmatic event publication without direct connection management. Just like S3 event notification, using Redshift Data API, you can get those notifications, and those notifications you will use Event Bridge, which acts as the orchestration layer, routing your Redshift job completion events to a Lambda function that records the metadata in DynamoDB. This serverless workflow eliminates polling and ensures scalable event-driven monitoring. Data engineer must securely transfer 5 TB of mixed format files from an on-premises data center to S3. About 5% of the data changes daily, and updates need to be synchronized regularly. The transfer should be automated, scheduled, and operationally efficient to minimize manual effort. We are going to use data sync for this. Why? Because this simplifies hybrid data movement by handling incremental updates, encryption in transit, task scheduling, and automatic verification. It supports multiple file formats and efficiently transfers only changed data blocks, reducing cost and time. The service integrates directly with S3 and can be triggered on a recurring schedule without custom scripting. Data engineer manages a financial database running on an on-premises Microsoft SQL server. Monthly data migrations to RDS for SQL Server have become expensive and time consuming. The engineer needs a cost effective solution that minimizes downtime during migration. This is a giveaway question. Are you going to use AWS DMS or database migration service, which provides continuous data replication with minimal downtime by supporting change data capture? It transfers only changed data after the initial load, reducing bandwidth and operational cost. DMS handles schema conversion, monitors migration status, and supports secure fault tolerant data pipelines. Data engineer is building an hourly ETL pipeline using AWS Glue to extract data from Amazon RDS and MongoDB. Then perform transformations and load the output into Redshift for analytics. The engineer needs an automated low maintenance design that supports secure connections and scheduled execution. We are going to use Glue connections, which provides seamless access to multiple data sources without managing credentials or networking manually. Triggers in Glue, they enable automated scheduling of jobs, ensuring timely and consistent hourly updates. The serverless nature of Glue eliminates the need to manage clusters or orchestration infrastructure, minimizing operational overhead. Even though you can schedule Glue jobs from here, typically having it done from Event Bridge makes sense and puts everything in a single place. Because if you have to schedule step functions, let's say, how are you going to do that? From Event Bridge, then you will have two things in two places. So, I always recommend you to use Event Bridge. If you have one or two Glue jobs, then go ahead and use the Glue to schedule it. But yeah, that's my recommendation. A data engineer manages an Amazon Redshift cluster running on RA3 nodes. During heavy workloads, query performance degrades due to limited concurrency. The engineer needs to automatically scale read write capacity to handle spikes in query volume. Interesting. Redshift concurrency scaling. It automatically adds transient clusters to handle bursts in query load, ensuring consistent performance. By enabling it at WLM or workload management queue level, only specific queues benefit from on demand scaling, optimizing cost and resource usage. RA3 nodes, they support this feature natively, allowing compute scaling without moving your data elsewhere. A data engineer needs to orchestrate multiple Athena queries that run daily with some queries lasting over 15 minutes. So this 15 minutes is very important because whenever they give something like this, they are telling you not to use lambdas for this solution. The solution should be automated, cost effective, and capable of handling sequential execution without manual intervention. I have not seen any use case where we would have to schedule Athena. Normally, at my workplace, we use Athena to query and see data on S3 ad hocly. If, we have glue jobs, but querying source data from glue, running a glue job for the sake of that is expensive. You have other options which we also use, which is glue notebooks. But again, even that behind the scenes, it triggers worker nodes. That is expensive as well. So the easy way for us to query our source data to check certain data or to debugging certain things is using Athena. Because we have a data lake, we query using Athena. But that's ad hoc. I haven't seen a use case in my work life though to schedule Athena. But for this scenario, we are going to use step functions, which can manage long running processes like Athena queries by combining lambda tasks. You might be thinking, didn't you just say lambda, eliminate lambda? But well, I'm talking about for the entire thing, right? They said they have Athena queries. All the queries they take 15 minutes. So if you are going to trigger all the queries from lambda, then yeah, you cannot. But this solution, what it is doing is using step function, you will run one query in one lambda. Once that is done, you will trigger another query in again another lambda, etc. So all queries combined takes 15 minutes, not one at a time, correct? That's why we will use this with a combination of lambda tasks to start the queries, just to start the queries, okay? Because we trigger them asynchronously. Asynchronously means what? You trigger it through lambda, then you lambda will come back saying it's done. You might be thinking like, how can you do that? The query might have not been done. Well, that's fine. That is called asynchronously. Okay. Synchronously means you will trigger it through lambda and lambda will sit there and wait until the query gets finished. Sometimes query might take more than 15 minutes. So lambda is not. But this case, yes, you can do that. Actually, we do the same thing, but Redshift stored procedures. So using lambda, we used to do. Now we directly call Redshift API from step functions. So from within lambda, you can trigger glue jobs. From within lambda, you can trigger bedrock jobs. You can trigger Redshift stored procedures using Redshift API and whatnot. But you will trigger them asynchronously, which means it will trigger and it will forget. Then you might be thinking, then how will we know if the query is finished or not? Well, that's where the polling comes into. Okay. So what happens is in step function, you will trigger this, then you will have a polling in a sense. Once this triggers, the Athena will give it a query ID. Then you will store that query ID in step function, and step function will wait. Let's say we will tell it to wait 1 minute. It will sleep 1 minute. Then it will go check Athena by giving the query ID saying, is it done? If it is not, then it will go and sleep for your configured time. Then it will go and check. That is called polling. Okay, to poll the query status. So why you are doing this? Well, then you don't have to make the lambda sit there and wait for the query to finish. The asynchronous comes into picture or advantage when you want to do that, because some of our stored procedures, Redshift stored procedures, takes 1 hour. Do you want to trigger it through lambda or any glue job for 1 hour and then sit there and wait? No, you trigger it, come back, then poll the Redshift API, or in this case Athena API, with the query ID saying, is my query done? Is my query done? Of course, you are not going to do that every second or every minute, because you already know how often your queries will run. So you will configure that amount of time. So this avoids the 15-minute lambda timeout limit while maintaining a fully serverless pay-per-use design. It also enables error handling and retry logic for reliable daily execution. Yes, step functions has that capability. And by the way, if you are enjoying these scenarios and the explanation, and in between me telling my real work experience. If this is helping, please do subscribe to the channel and like and comment on these videos because we need that a lot. As you know, we used to have a old channel which we had 40,000 subscribers, but then again it got closed. So I reopened this an year ago, but didn't upload it until mm, a month ago. I've been again actively uploading it. So we don't have that many subscribers, and since I didn't upload for almost 9 months, even YouTube is kind of is not pushing my channel with the you know the algorithm and whatnot. So the only way it does is if you like, comment, and subscribe to the channel. So the more activity on a video there is or a channel there is, YouTube pushes that particular channel into the search results. So please, please, please do that. And okay, only do that if you're enjoying or if you think whatever you are learning here is useful. Otherwise, it's okay. You don't have to do it. At least once you write the exam, if you pass the exam, and if you think this video helped, please do come back and leave a comment, like, and subscribe to this channel. That will really help me a lot. And again, as promised, I'm going to keep everything on this channel free forever. Even in my previous YouTube channel, everything is free. So I want to keep that here as well. In order for me to do that, I would need your support. All right. A company is migrating its big data workloads using Apache Pig, Uzi, Spark, HBase, Flink from on-premises systems to AWS. The workloads process petabytes of data in seconds, and the company wants serverless or managed options with minimal operational overhead while maintaining. Again, whenever they say this minimal, which means they are hinting you to pick a serverless or fully managed service. And in this case, since we have that many big data Hadoop tools, the only way to do it is using EMR. I mean, there are other ways, but if you want a fully managed way, then EMR is the only thing. This is a fully managed Hadoop ecosystem that supports Spark, Hive, Pig, HBase, Flink, Uzi, etc. It allows the company to maintain existing code while benefiting from auto scaling, managed clusters, and you can even use EMR serverless for a near serverless experience. EMR's optimized infrastructure ensures performance comparable to or better than on-premises clusters. And by the way, if you are using batch processing at your work location, then we used to use EMR. I would say 3 years until 3 years ago, we used to run our Spark jobs, but our production load was batch load, which used to happen, which used to start at 7 p.m. EST till 3 a.m. EST. So what is this? 5 plus 3, 8 hours, right? In an entire day. It doesn't make any sense for you to run EMR 24/7, right? So we used to start an EMR around at 6:30. The reason at 6:30 is because sometimes if there weren't enough machines available on AWS, it would fail. So we just gave, it used to take around 10 minutes for it to provision. So if it fails at 3:40, then we will try again and again. So for that reason, we put 30 minutes uh, gap. So it will start then, and as soon as our last job finishes, we put a dependency saying go ahead and terminate the cluster, then it will terminate. So we kind of only used EMR 8 hours. Most of the companies do that. If you have a use case, I guess I hope you to do that as well. So you will schedule it to start at 6:30, and then you will put a job dependency. You won't schedule it to finish at 3 a.m. because sometimes your jobs might run longer. So there will be a dependency on your last job that runs. A data engineer is building an ingestion pipeline to move data sets into S3 data lake. During profiling, the data set is found to contain personally identifiable information. What is PII? This includes address, phone number, SSN number, Aadhaar card number, and etc. That must be detected and obfuscated. Obfuscated in the sense like even though sometimes in movies they will show you, right, the high confidential document, but everything will be scratched out or something like that. Yeah, that's what obfuscated means. Before storage, the solution must be automated and require minimal maintenance. Again, this just means try to use fully managed services. So in order for this, we are going to use something called detect PII transform, but where again Glue Studio. So AWS Glue Studio, it simplifies your ETL design through a visual interface, allowing data engineers to integrate built-in transforms like detect PII. The Glue data quality rule set can define transformations to mask or redact detected PII values. Step functions, it can manage the workflow to ensure the dataset is cleaned, transformed, and then loaded into S3. This approach avoids custom coding or manual intervention because step functions is serverless, Glue is serverless, so pretty much everything is serverless. A company runs multiple ETL pipelines using Glue and EMR to process data from operational databases into S3 based data lake. The company wants to automate the orchestration of these jobs to reduce manual coordination and improve reliability. So whenever you see orchestration, some on AWS you have step functions, then you have Apache Airflow, and then since this is Glue, you have Glue workflows as well. So you will get confused which one to pick. Remember, if it is EMR and only Glue, then you can just go with Glue workflows. Okay, because this allows data engineers to define dependencies between multiple Glue jobs, triggers, and crawlers in a single pipeline. It provides visual orchestration, centralized monitoring, and native integration with Glue triggers and data catalog, all without requiring external schedulers or workflow managers. This makes it an ideal choice for teams already using Glue and EMR. Okay, but if you have complex orchestration scenarios, if you have other tools that are being integrated, for example, like AWS Redshift APIs, like stored procedure triggers, etc., then go with the step functions. And if you have custom logics that you want to write to orchestrate that is not available in step function, then go with Airflow. Okay. The data engineer analyzed access patterns for objects in S3 bucket. The data is frequently accessed for first 6 months, infrequently accessed for next 18 months, and rarely accessed after 2 years. The engineer needs to design a lifecycle policy to reduce storage costs while maintaining high availability. This is a textbook question, Stitha Pregnance. The reason I am saying textbook is whenever the question talks about infrequently accessed, then go with infrequently accessed IA. S3 standard IA. This provides high availability at lower cost for infrequently accessed data. While Glacier Deep Archive offers the most cost efficient option for long term retention with annual access patterns. Right? Long term or archival purposes, then you will use Glacier Deep Archive. This combination balances cost and durability without compromising accessibility when needed. So if I go back to the question, for frequently you will use standard. For infrequently used, you will use infrequently accessed, and for rarely, you will use Glacier Deep Archive. A data engineer manages an ETL Amazon Redshift cluster used for analytics. The sales team maintains a separate BI cluster and needs access to ETL data for weekly summaries. The solution must allow cross cluster data access without affecting the ETL cluster's performance or resource consumption. Again, you are going to see a feature that you might have seen in Snowflake, which is called Redshift data sharing. Okay. This allows secure live access to data across clusters without copying or duplicating it. You might be thinking like, why would I need it? Well, let me give you again an example of how I use it at my work. We use data sharing at my work as well. Why? Well, this is why we use it. Okay. So imagine you are, I mean, our data doesn't contain any secure information or anything like that. So we can use our production data in dev and QA without any problem. So sometimes when you are loading your data in dev or QA, what happens is our business users wants us to test our jobs using production data, right? So the one way you do is you move your code to production and then you execute it there, etc. But again, this is your testing, it is not finalized yet. You did, business users didn't give you a sign off, you didn't show them the results, etc. So then what we do is we load our dev or QA environment using the production data. But how do we do that? Well, using data share. Using data share, we will make the production tables read only available in our lower environments. Again, remember, read only, not write, of course. Data share, read only. So this, you are not copying your production data to other environments. Instead, you are making queryable production data queryable in your other environments. Again, again, some people might be like, oh my God, production data, how come you are, we don't have that problem. Our data is not that. Our users are fine with it. So hold on, okay? Hold your horses. The BI cluster queries shared data directly, and Redshift automatically manages metadata and access permissions. This design minimizes CPU and IO load on the ETL cluster while keeping data fresh and consistent. And I have recently seen another use case, which is it's kind of the same scenario that I explained right now, but instead of you giving somebody access to production data in dev, you are going to do it the other way around. You will make dev queryable from production. You might be thinking, why would one wants to query dev in production? Well, sometimes you want to compare the data that you loaded in dev and production. So instead of you making prod available in dev, you are making dev available in prod, which is totally fine, right? So you go to the production and then you write a maybe a minus query to compare the production table with the data you loaded in dev to see if the data is matching or not. Again, these use cases differ company to company. But yeah, I mean, you can note down whatever scenarios that I'm explaining and put in your resumes and use these as your own scenarios in your interviews. A data engineer must perform a one-time analysis that combines data from DynamoDB. Where is my cursor? Oh, here we go. RDS, Redshift, and S3. The goal is to join all data sets efficiently without creating or maintaining new ETL pipelines. The approach must be serverless and cost effective. Of course, it has to be. Well, for this, we are going to use something called Athena Federated Query. This allows SQL based access across multiple AWS data stores, including S3, RDS, Redshift, and DynamoDB without data movement. It leverages AWS Glue Data Catalog for schema management and executes queries on demand ensuring the engineer only pays for the compute resources used per query. This avoids the cost and overhead of provisioning clusters or building one-time ETL jobs. I have never used this, so no comments here. A company uses Amazon EMR cluster to run Apache Spark workloads for large-scale data analysis. The workloads are long-running and performance critical. The engineering team needs a design that balances cost efficiency, reliability, performance consistency. How can you do this? Well, Amazon S3, it decouples compute and storage. We already know that, allowing data persistence even when clusters are terminated, reducing costs compared to HDFS based storage, which is the storage that you would use if it is EMR. Graviton instances. These provide better price performance compared to x86 instances for EMR workloads. Together, they ensure the cluster is cost effective, reliable, and easy to scale for future workloads. Okay, so you will use S3 as persistent data, whereas the Graviton instances for core and task nodes in the EMR cluster. A data engineer needs to design a real-time analytics pipeline that ingests several gigabytes per second using KDS, Kinesis data streams, and delivers the data into Redshift for near real-time insights. The solution must integrate easily with existing BI tools and require minimal operational management. For this, we will use Kinesis Data Firehose because this simplifies streaming ingestion by automatically batching, compressing, encrypting, and delivering data to S3. Redshift can then use the copy command to efficiently load data from S3 into analytics tables at scale. This approach eliminates the need to manually manage data transfer scripts or ETL code and provides near real-time data availability for your dashboards. A data engineer maintains an ETL pipeline that prepares data stored in S3 for a quick site dashboard. As new data is added daily, the glue jobs and dashboard queries have become slower over time. The engineer must improve ETL performance and maintain dashboard responsiveness. Okay, partitioning. Partitioning data in S3, it enables Glue and Athena to skip irrelevant files during queries, significantly reducing scan time and costs. Increasing worker capacity improves transformation throughput, especially for large data sets that have grown over time. These combined optimizations minimize latency for both glue job execution and quick site queries. If you are wondering how the partitioning actually help with this, let me give you my example that we use at our work. So we get incremental data every day. So whenever you get once data into your S3, you store that based on your today's date. So for example, today is what? I guess today is 28, 2025. So you create a folder with this name and you put the data in there. Okay, so that's your partition. So you are partitioning based on the date. How is that going to help? Well, this partition is going to be added as a column in your table. And if you are going to query, let's assume only today's data. I mean, that's what you want to process, right? Incremental data set. Even if you have your entire history, if you are querying on this date column using in filter, then it will only scan this particular folder. It won't even go into other folders. So that's the power of partitioning. It doesn't go into all the data folders. It will go only into the partitioned filter that you actually applied. Okay, that's the interesting story there. Okay, so I want you to take a break here. It's been almost an hour. So take a break, maybe have, walk for 10 minutes. That is healthy. Every 1 hour you need to walk at least for 5 or 10 minutes. Do that. Have some water, tea, coffee, whatever it is, and then come back. Welcome back. Let's continue with our exam study guide scenarios. A data engineer needs to orchestrate an AWS step functions workflow that processes a large number of data files um, stored in S3. Each file must undergo same transformation logic independently in parallel to speed up the processing and improve efficiency. How are you going to do that? Same transformation logic. Well, one way not one way actually, transformation logic can be put into a lambda, it can be put into a glue, it can be put into redshift stored product depending on where your data is, etc. Okay, but with whatever the question is asked, what are you going to use in step functions? Well, I'm going to use something called map state. Where is it? It is this here. What does this do? This allows step functions to iterate over an array of items. In this case, we have several files and execute a defined workflow for each element concurrently. You might be saying, don't we have a parallel state in step functions? Why not use that? Well, parallel state runs a fixed set of branches, whereas the map state dynamically scales based on the input size, which is ideal for batch or file level parallelism. This minimizes orchestration complexity while maintaining performance and scalability. And as I'm doing the rest of the video, I'm going to give you the real-time use case in my project, how I use this. Okay, maybe that will clear up what we are talking about here. So I had a business scenario or logic or use case where I think I implemented this maybe 3-4 years ago. The requirement is this. Okay, we get market data. What is market data? Well, market data is something where you get data from the market, but what kind of data? Well, it has everything. Like for this particular, let's say, data engineer with this much years of experience, how much are they getting paid outside? Or things like this particular item, how much are they selling outside, etc. In the market, whatever they are selling in the market. But of course, there will be several things. Why would you want to get all of them? We won't. We will only get the data from the market that maybe my company is actually producing, so that it can use that data to compare and use it in our analytics and compare it with our prices and whatnot. So we get market data. How do we get it? I mean, we have a team at a organization level where they get the market data and distribute it to different teams. They host it on their cloud and they give access to us through API. Okay. And market data, as I just mentioned, they maintain it using formulas. Okay. A formula would look something like in this industry, X industry, in this Y location, in this category, this product during this duration, let's say 2024 Q1, what is the price of this? So this will be like a formula, and this formula is created by this market data team so that people can query it instead of using SQL and whatnot. Since they have API, using this formula, we get the data for however much long it is. If it is just let's say, you can also put functions like give me max of this during this um, duration, or min of during this duration, or give me the top 10, top 5, top 1, etc. Depending on how much data we are getting, it will be either one record or 10 records, but they will give us as uh, JSON file. Anyways, coming back to this API, we need to supply these formulas to this API, and the API will give us JSON files. For each formula, it will give you a JSON file, one single file. Now I have to store this file. So I have formulas. How many do I have? I have about 5,000 formulas, which means I have to make 5,000 calls to the API, and I will get 5,000 files. I need to merge all those files and put into a single consolidated dated file. So this is my requirement, and using AWS, I have to implement it. Okay. So what do I do to connect to the API? Of course, I have 5,000 formulas. First thing, I cannot hard code that in. Let's say if I want to implement or write my API code, I will use Lambda, because I know that this data is not huge. It is just single line data. If you are getting, let's assume 100 records, even that is not huge. So I know that my API call would return within 15 minutes. If it is not, API would complain first of all. So for that, I chose Lambda. That logic will be there in the Lambda, but I need to run this Lambda 5,000 times. So I need an orchestration tool. So I went ahead with step functions. So I have step functions, but I cannot hardcode 5,000 of them in step functions. I can put it on S3 and I can supply that data to the Lambda function or step function and etc. But the thing is, if I have to add more formulas, because business wants more commodity or market data, so I would have to apply change it frequently. And by the way, these 5,000 formulas are created by our business users using another portal that they have. So they use a portal. When they enter backend, it gets saved in a database. From that database, we have to query it into our system. So for that reason, we query it from their system, which is a SQL server, onto our S3. And once it is on S3, we copy it to our Redshift. And from Redshift, in this step function that I spoke about, we read it. So the first step is read the formulas. Okay. Then you need to call this Lambda 5,000 times. Again, you cannot call at a time the 5,000 because the API don't allow it. I did a stress test on the API, then decided I can send 7 formulas at a time to the API. If I send more than that, it will time out, which means I need to run 7 formulas, which means I need to trigger this particular Lambda 7 times concurrently. So can I use the parallel state? If I use the parallel state, how parallel state work is, you will have the parallel state box. In it, depending on whatever you have, you need to place different states or whatever it is called, steps, right? If I have to trigger the Lambda this many times, I have to give that. That is not appropriate, is it? These all get executed at the parallel at the same time. But again, I need to pass these values, and I don't want to paste the Lambda there and give the hardcore the values, etc. So I have to place 5,000 of them. So parallel is not useful here. Where is parallel useful? If I have, let's assume that a Lambda, let's assume that I'm extracting from 5 different databases, and each Lambda does its own thing. Then if you want to execute them parallel, you can have something like this. But for this, it's not the case, because I'm going to use the same transformation logic. Why would I put this many times? So instead, you will go with map state. Map state, you will only have one single state. Then you will have your Lambda in there, and then there will be a concurrency parameter where you will enter your value, which is 7 for me. So the first step is Redshift. It will read all the 4,000 or the 5,000. Then this map state, to this map state, it will only give 7 at a time, 7 formulas at a time. So it will trigger 7 lambdas, and the step function will wait until those 7 are done. Once it finishes one, then it will keep on supplying them to make the concurrency 7 all the time. So that's how you loop it. So that's how the map state works. You just give the concurrency however many time in concurrently you want to run, it will trigger it. Once you do this, once this is map state, by the way, once it triggers all the 5000, again it is writing the files, right? It's not merging yet. So all those files will be returned to S3, and I will have another process here, which actually combines, merges them into a single file. Once it merges into a single file, then again I write it to Redshift. So that's all there. But the point of this scenario is the Lambda or the map state in regular. That's how I used it. Um, and there were multiple other issues as well that I faced while doing this, which was you cannot, my 5000 curves queries, the whatever you send to the API, they were exceeding the step function payload limit. Payload limit is 650 KB. That is the payload limit of a step function. So if it is more than that, it cannot handle it. So what I had to do is, in this particular Redshift reading Lambda, I split this 5000 into chunks, 500 chunks, like divided by 500. So this became total 10 chunks. So my Redshift, what it does is, it will only query 5000, then it will keep on supplying 777. Once that is done, it will again pass the next 500 and etc., because of this size limit. So there were several issues, but you got the architecture, right? So you can use this in your interview and explain it to them. I hope it's useful to you guys. A company migrating legacy application data to an S3 based data lake discovers that the dataset contains duplicate records. The data engineer must detect and remove duplicates efficiently using low code serverless approach. There is only one, right? Low code serverless approach means AWS Glue. Again, do you remember that question where we used PII transform? Similarly, here we have another transform which is called find matches transform in AWS Glue. This leverages machine learning, but why? To detect duplicate records without requiring explicit matching rules. If you have to figure out matching rules or matching or duplicates, you would have to write your own rules, right? But here you don't have to, because it comes with a built-in transform. Okay, this can automatically learn patterns of similarity because of the machine learning, and generate confidence scores for potential duplicates. This approach reduces manual coding, scales easily, and integrates seamlessly with S3 data lake architecture. A data engineer is implementing an analytics solution using Redshift Spectrum to query data directly from S3 data lake. To minimize query latency and maximize efficiency, the engineer must structure and store the data in a way that delivers fastest query performance. Thitha Pragnas, you already know the answer, don't you? As soon as you see external data querying files from S3, the only thing that actually minimizes latency, maximizes efficiency is Parquet, or there is another one, Arc as well, but mostly Parquet. Because they are columnar formats. Columnar formats, what do? They store data by column instead of row, enabling Redshift Spectrum to read only the columns needed for a query, drastically reducing I/O and improving performance. Data partitioning further limits the number of files scanned by pruning irrelevant partitions during query execution. Together, these optimizations reduce both cost and query time while maintaining flexibility. A data engineer needs a Lambda function to insert and update records in RDS that resides in a private subnet. The function must connect privately without internet access. and use the simplest setup with minimal ongoing maintenance. I think I told you, right, when it says without internet access, you should use private link. But remember, you should use that only if you are connecting to services that are outside your VPC. Correct? But in this question, there is we are connecting to RDS, which is inside your VPC, right? It's not outside, so you don't need the private link. Then how do you handle the traffic between these without internet access? Well, it's very simple if you ask me. Running the Lambda function in the same VPC and subnet enables private connectivity via the internal AWS network. Got it? No internet exposure. And granting inbound permissions on the RDS security group to the Lambda security group. That is important. If you want to maintain not just private access, but you to the, what do you call it, a principle of least privilege, which means only give access to what is needed. So to this RDS, you are only need Lambda to query it. So instead of giving IP addresses or etc., you are giving or granting inbound access to the RDS only to the Lambda security group, which allows traffic only on the database port, ensuring secure communication without opening the instance to the public internet. This avoids NAT gateways or VPC endpoints. Again, VPC endpoints you will use if you are trying to connect it to services that are outside your VPC. Okay, and NAT gateway you already know. If you don't know, you will use NAT gateway if you want one-way access to the public internet, but not the other way around. So when would you need something like this? If you want to update your OS or software, you of course need to reach out to the public internet, to the tools website to get the update. So NAT origins here, goes to the public, gets the updates. But if you somebody tries from public to connect to here, it won't. This is one way route. A data engineer needs to expose a Python script that can be occasionally invoked through API gateway by a front-end React.js web app. The script must run only when triggered and return results to the API gateway endpoint with minimal infrastructure and management overhead. How are you going to handle this? Well, as soon as you see Python script, you know what to do. You are going to use Lambda, which is a fully managed event-driven compute service that automatically scales and executes code in response to API gateway invocations. If you don't know how that is done, the project playlist I showed you in the beginning of the video, go check it. We did at least 5 projects where we create APIs on the API gateway, which actually run Lambda code behind the scenes. And we are going to use provisioned concurrency, which keeps Lambda environments pre-initialized. Provisioned concurrency, what does it do? It puts or makes Lambdas readily available, sitting there waiting to be triggered or used, which ensures consistent and low latency response times for occasional but performance sensitive requests. This removes the need to manage servers or container clusters like ECS or EKS. A data engineer must enable cross account log delivery so that CloudWatch logs from the production account can be streamed to the security account for centralized analysis. The company wants to use Kinesis data streams as the transport layer between the accounts. Well, we are going to host, or by hosting the Kinesis data stream in the production account. Why would you do that? So that CloudWatch logs can deliver data directly without additional routing or permission changes. Correct? Because that's what we wanted to do. Because CloudWatch from the production account, right? That's why we are doing that in that account so that you don't have to manage cross account, etc. But the security account, it's a different account, right? This is production account, then you have another account. That account assumes a cross account IAM role that grants read permissions on the stream for log collection and analysis, which is in the production account. This ensures secure, scalable, and real time delivery of log data while maintaining clear separation of accounts for compliance. So, you don't have to write the logs in the security account. Instead, you will keep them in the production account, then read from the security. A data engineer manages a transactional data lake on S3 that receives daily JSON snapshots from an upstream system. Each snapshot is a full extract containing both old and new records. The engineer must identify and apply only the changed records each day in a cost efficient, scalable way without reprocessing all data. So technically they are talking about CDC, change data capture. So you need to only capture the data that is actually changed, not the data that you already got yesterday. So we have actually a scenario like this right now. I mean, we do this. Pretty much most of the companies do this as well. And what is that scenario? So you will have your sources. Then you need to read data from there incrementally. What does incrementally mean? Like you need to only get the data that that came into source since your last processing, right? Let's assume that on day 1 you read the data at 9 p.m. On day 2 you only want data from this 9 p.m. till today's 9 p.m. That is kind of reading incremental. You are not reading both the data. You are only reading the data that came after yesterday's read. So that is incremental. And most of the companies right now put the data in data lake. Either it is S3 or Azure or Google, doesn't matter. They put it in a data lake. Correct? In our case, this on S3 is done by some other team. So from S3, what do? We read this incremental data because on S3 they store the data in the Delta format. We read the data and load it into our Redshift. But the problem is we don't want Redshift anymore. We want to eliminate it. So what we are trying to do is, but what are we doing here in the Redshift? We transform this data into DIMS and facts. And we also, along with this, we are also, if there are any data that is deleted in the source, we mark the records as deleted. That as well. What else we do? If any data is updated, then we update the data in here. Whatnot, we do all kinds of stuff there. But eliminating this means we're eliminating these tables. Do you want to do that? No, we just want to eliminate Redshift, but we still want to use S3 because it's cheaper. But again, S3 is what? It's an object storage, right? This is a kind of you can query SQL. You can use SQL and you can query its table format, whatnot. How does Redshift kind of supports ACID transactions? But does S3 has all that? Well, that is this question, right? And the answer is yes. Modern open data lake formats, they support ACID transactions, they support merge on read, and they also support time travel capabilities, enabling efficient CDC operations, change data capture operations, directly in S3. These formats compare incoming records to existing data and they apply only changes, eliminating the need for full data daily reloads or complex comparison logic in Lambda or RDS. You don't have to use. Right now we do all this using Glue. So if we were to follow that, we don't need to use that. That's the advantage. We have to implement this. A data engineer observes slow query planning in Athena when querying partitioned data stored in S3 with metadata managed by the Glue data catalog. The performance bottleneck arises from the large number of S3 partitions. The engineer must optimize query planning to reduce latency and cost. How can they do that? Well, for that we have two options. When datasets have thousands of partitions, Athena spends significant time retrieving partition metadata. So that's where the partition indexes comes into picture. This accelerate partition pruning by allowing Athena to skip unnecessary partitions. And then there is something called partition projection, which avoids storing every partition in glue by deriving partition values from S3 prefixes dynamically, removing catalog dependency and drastically reducing query planning overhead. So a combination of these two will achieve what the question asked us. A data engineer needs to process real time streaming data with time based aggregations over windows of up to 30 minutes. The solution must be highly fault tolerant, scalable, and require minimal operational management for continuous analytics. So you might be thinking, since it's streaming, well, why not go with Kinesis family, one of them, right? But you need many things here which are not actually um, provided by those. That's why we will go with Amazon managed service for Apache Flink. It used to be known as Kinesis Data Analytics, but they renamed it to this. Why this? Because this is a fully managed stream processing environment for real-time analytics. It natively integrates with Kinesis data streams and Firehose and supports tumbling and sliding windows and handles late arriving events and duplicates automatically. You don't have to implement any solution. It does it by default out of the box. It maintains stateful streaming computation with high fault tolerance through checkpointing and state recovery, eliminating the need for need to manage servers or complex Lambda workflows. A data engineer must upgrade multiple Amazon EBS GP2 volumes to GP3 to reduce costs and improve performance without downtime or data loss. How can you do that? Well, this is an easy one. Because EBS supports seamless volume modification, allowing you to switch volume types from GP2 to GP3 without detaching or recreating volumes. The operation is online and transparent to the EC2 instances. This approach avoids the operational complexity of creating new volumes, copying data, or reattaching this. A data engineer is supporting a database migration from SQL Server on EC2 to RDS for SQL Server. During the migration, the analytics team must export large joined datasets daily from SQL Server and store them in S3 as Parquet files. The solution should be automated and require minimal operational maintenance. How do you do that? We are going to use Glue for this, which provides serverless ETL environment that can connect directly to SQL Server using a JDBC connection. It can read complex query outputs from a SQL view, apply schema inference, and configure or convert the output into Parquet format efficiently. The process can be handled or scheduled using Glue triggers without requiring custom Lambda logic or manual SQL agents. So you can see the flow mentioned here. A data engineer managing Redshift needs to detect and record query performance anomalies. Specifically, when the optimizer identifies potential issues like missing statistics, skewed joins, or suboptimal execution plans. The goal is to log such conditions for analysis and tuning. So for that, we are going to use STL alert event log. This provides detailed information about query execution anomalies detected during compilation or runtime. These alerts can include events like memory pressure, missing statistics, excessive skew, or suboptimal join strategies. Monitoring this table helps data engineers proactively diagnose and tune slow running queries before they affect production workloads. A data engineer must ingest structured CSV files into S3. Each file contains 15 columns, but data analysts typically query only one or two columns using Athena. The goal is to improve query performance and reduce cost by minimizing the amount of data Athena needs to scan. So the practice, what is the answer? You already know it. It's none other than Parquet. This is a columnar format that stores data by columns instead of rows. This allows Athena to scan only the columns being queried, significantly reducing data retrieval and query costs. It also provides efficient compression, which further reduces S3 storage costs and query latency. Glue can easily automate the transformation from CSV to Parquet during ingestion. A company with 5 offices across AWS regions, each with a separate HRIAM role. All employee records are stored in a centralized S3 data lake. The data engineering team must ensure that each regional HR department can only access employee data from its own region while minimizing administrative complexity, of course. How are you going to do this? We have seen a similar situation scenario, right, the pregnancy, where we mentioned the data within from that country has to be accessed in that country. I gave you an example of government rules that data should reside in their country, whatnot. So this is the same, and back then we used what lake formation, which provides centralized access control for data lakes built on S3. By registering the S3 data location and enabling column, row, or tag based filters, you can control which subset of data each IAM role can access without creating multiple buckets or complex IAM policies. Data filters allow fine grained restrictions based on region or other attributes. A data engineer is working on a data pipeline orchestrated with step functions where each state triggers EMR jobs that ingest data from multiple sources and load results into Redshift. The step function state machine was created manually, but the EMR jobs failed to start after deployment. The engineer must determine why step functions cannot run the EMR jobs. Not just this, not just EMR jobs, even Lambda or Glue, it's all the same. The first step you do in the step functions or the step function requires IAM policies that grant explicit access to the AWS services it orchestrates. In this case, EMR. If you are reading from S3, then S3 buckets. If you are writing CloudWatch logs. If permissions are missing, for example, since we have EMR, let's assume Elastic MapReduce run job flow permission or S3 get object, then step function cannot start EMR jobs. Additionally, when EMR clusters are launched in a VPC, they need correct route tables, security groups, and subnet configurations to access both input and output data sources. So, where will you get this information? Well, in the VPC flow logs. That's why you need to check VPC flow logs, which helps confirm if traffic between step functions, EMR, and S3 is blocked by networking rules or not. You can also use access analyzer and whatnot. A data engineer manages an application running on EC2 instances that currently store temporary data. The company now needs to ensure that application data persists even if EC2 instances are stopped or terminated. New EC2 instances will be launched from an AMI, and the engineer must design a setup to persist this data. How can you do that? It's simple. How? Because the data stored on instance store volume is ephemeral. What does ephemeral means? It means temporary. The data stored on instance store will be lost when the instance stops or terminate, which is the opposite to what the scenario is asking you. So if you want to persist the data, even if you stop, terminate your instance, you should use Amazon EBS volumes, which remain intact even after instance termination. Of course, assuming you configured delete and termination as false. The best approach is to launch instances from an AMI for compute and attach an EBS volume specifically for data storage. A data engineer currently uses Athena to run SQL-based ETL jobs using CTAS. What does this mean? Create table as select. The team now needs to run Apache Spark Analytics instead of SQL, but they still want to use Athena as the access point. The goal is to integrate Spark workloads with Athena seamlessly. How can you do that? Well, there is a feature in Athena which provides Athena. That feature is called Athena for Apache Spark, which lets users run interactive Spark applications directly from Athena without managing any clusters. This capability is configured through Athena workgroups. A workgroup can be set up to use Spark as the compute engine instead of the traditional SQL query engine. Data engineers can run Spark code in Python or Scala directly from Athena console, SDKs, or notebooks as well. A data engineer manages a data lake on S3 with partitioned paths such as this. When new partitions are added, the engineer must ensure that the glue data catalog updates automatically with minimal delay so that analytics tools like Athena can immediately query new data. This is actually, again, alert that I have implemented this solution. So this issue arises when you query data from tables that you created on top of S3 files, right? You queried them through Athena, but the tables in Athena are stored in glue data catalog, correct? Now your data is partitioned. Okay, so let's say today is 2025, month is 10. These are folders I'm talking about. Then the day is I guess 30. Now you go on, right? So today is this, but tomorrow you have 1031 folder, this prefix. This table is not aware of it, correct? When you created the table, let's assume you created the table this day. So once you create the table, if there are partitions, they won't be added by default. How will you add them? Well, once you do this, you can add partition, something like that, or there is a command called msck repair. What this command does is it will add any partitions that are not on the table but they are available in your S3 location. Cool. But this is manual. We want to do automatically. Same thing. Tomorrow I got another one. Then tomorrow you have to run again the msck repair and again another every day. So you have to, but do you go and run it every day manually? No. So what we did is whenever you get, so we have our S3, I think you remember our flow by now. We have our S3 events and then they will be stored in SNS, then they will be read SQS. Why SNS? Because along with our team, there are several other teams that read the same data set. So S3 event, you can only have one consumer. So you cannot have multiple people here. That's not possible. So you store those events in SNS and SNS can have multiple consumers. SQS cannot have multiple consumers as events. So you need to use SNS so that multiple people can consume the same thing. Why SQS? Because at the same time we might get hundreds of thousands of changes or events. So we don't want to lose them. Instead, we want to buffer them using SQS and then a Lambda will be triggered. What does this Lambda do? Lambda checks in the event. Is it a partition? Did they add a new partition? If so, then it will automatically run msck repair. Did they delete a partition? Deleting a partition cannot be fixed with msck repair. Instead, you have to drop it. Since we have the information of that partition in the S3 event, we will issue a command called drop partition and then the partition. So you will drop any files that are deleted on the S3 side. And then as you can see, every time you get that file updated, added, deleted, then Lambda will automatically run so that you don't have to run this manually. That is our approach. But here, it's a different approach that I am going to show you. Okay, you can run. This is one method. You can also run glue crawlers as well automatically, so that crawlers will go and fix them. Or as I said, you can run MSCK repair. But the thing is, sometimes if you run manually, it introduces latency. But the most efficient method is to programmatically register the new partitions in real time using create partition API. I was not aware of this, or maybe it is a new feature. I don't know. There is something called create partition API when data is written to S3. So this ensures near instant synchronization between your S3 and the glue data catalog, allowing new partitions to be queryable immediately in Athena. Maybe I need to look into this, and maybe we need to change our architecture. A data engineer at a media company needs to ingest data from third-party SaaS applications into S3 data lake. The company plans to use Redshift for analytics, but wants a fully managed low maintenance solution to transfer your data from SaaS platforms to AWS. Whenever you see third-party SaaS applications, there is only one tool that you can use, which is called AppFlow. AppFlow is a fully managed integration service that connects SaaS applications like Salesforce, Google Analytics, or ServiceNow directly to AWS data stores such as S3, Redshift, Glue Data Catalog. It allows secure, scheduled, and near real-time data ingestion without writing custom ETL code or managing infrastructure. AppFlow automatically handles API authentication, schema mapping, and incremental data syncs, significantly reducing operational overhead. A data engineer uses Athena to query sales data stored in S3. The and what is the query to extract this? So I will write it here. Select product name, sum of sales amount from sales data. Looks like the query is missed, so never mind. And we are putting where year equals to 2025, and then they are grouping by. Okay, where did that go? Group by product name. It's not a crazy query, it's a simple query, right? So this is the query, but some products are missing from the query results. Even though they exist in the table, the engineer must identify and correct the issue to ensure all valid products appear in the output. So what can you do? So in Athena, the where clause filters rows before aggregation. Okay, what does it do? Where filters your rows before aggregation. If certain product rows have null or zero sales amounts, they are excluded or aggregated incorrectly. So what you are going to do, you are going to add having clause, which applies conditions after aggregation, ensuring products with valid but zero or missing totals are appropriately handled. By adding having sum of sales amount greater than zero, you include all aggregated products with measurable sales while filtering out those with no valid amounts. That's the mystery. A data engineer needs to perform a one-time query on data stored in Parquet format in S3 bucket. The task involves retrieving only one column from large Parquet files, and the engineer wants to avoid setting up complex infrastructure like Glue or Athena for this single query. How can you do that? Well, you should already know there is something called S3 Select, which enables direct querying of object data within S3. by using simple SQL expressions without needing to load or move the entire data set. Since Parquet is a columnar format, S3 Select can efficiently fetch only the required column, minimizing data transfer and cost. This approach provides provisioning or managing additional AWS services such as Glue or Athena, making it ideal for ad hoc lightweight queries. You might be asking, well, if there is cell S3 select querying on top of S3 itself, why do you need Athena? Well, this you can only query on one single file. If you have a folder and if you want to query on all the files, this is not possible. This is on a single file. A data engineer manages a data warehouse in Redshift. The warehouse includes materialized views that must be refreshed on a recurring schedule to keep analytics up to date. The engineer needs a simple low maintenance solution to automate the refresh process. How can they do that? Well, there is a feature called Query Editor V2, which includes a built-in scheduling feature that allows users to run SQL statements, including refresh materialized view, at defined intervals without requiring additional services like Airflow, Glue, or Lambda. This is the most straightforwardest way to automate refresh operations directly within Redshift environment, requiring no external orchestration or scripting. A data engineer needs to orchestrate a small data pipeline consisting of one AWS function and one Glue job. The pipeline should run the Lambda function first, followed by the Glue job, and it must integrate seamlessly with other AWS services while requiring minimal management overhead. You already know that. To orchestrate, what would you use? You would use step functions, which is a serverless orchestration service that natively integrates with both Lambda and Glue. By defining a state machine, the data engineer can manage the order of execution, handle retries, and monitor workflow progress, all without maintaining infrastructure. Step functions simplifies control flow logic like error handling, success failure transitions, and parallelization while remaining fully managed and cost efficient. A company needs centralized metadata catalog for multiple AWS sources, including structured data and semi-structured data. The catalog must update automatically and detect schema changes with minimal operational effort. And we already know the answer. Glue Data Catalog acts as centralized metadata store for all AWS Analytics services that includes Athena, Redshift Spectrum, EMR. Then you have Glue crawlers, which automatically connect to your stores, then infer schemas and updates the catalog when new data or schema changes occur. This eliminates the need for manual metadata management or custom Lambda scripts, providing serverless automated solution. A data engineer manages DynamoDB table operating in provisioned capacity mode. The workload follows a predictable pattern. Low usage on weekends and a sharp spike every Monday morning. The company must maintain consistent performance during peak load while avoiding unnecessary costs during idle times. So, when using provision mode, DynamoDB requires manual or automated scaling to match traffic demands. Application auto scaling. This allows scheduling predictable capacity changes, setting higher read-write units from 6 a.m. to 10 a.m. on Mondays and then lower on weekends because we already know the patterns. Whenever you know the patterns, you always should go with scheduled scaling. This approach ensures smooth performance during high load while minimizing costs during downtime, more cost effective than switching to on demand for predictable patterns. A company plans to migrate its on premises Hadoop clusters and Hive Metastore to AWS. The company needs a serverless and cost effective solution to maintain the data catalog in the cloud after migrating its Apache Hadoop workloads to EMR. I just mentioned it. As soon as you hear data catalog, you have to pick Glue Data Catalog, which provides serverless centralized metadata repository compatible with Hive as well as EMR. Migrating Hive metadata via DMS allows schema and table definitions to be retained while eliminating the need for maintaining a separate Hive metastore database. Once the data resides in S3, glue crawlers can automatically infer schema updates and sync with EMR, enabling easy integration with analytic tools like Athena and Redshift Spectrum. A data engineer manages a provisioned Redshift cluster with 5 RA34X large nodes. One node consistently runs above 90% CPU utilization, while the others stay under 15%. Queries on the overloaded node get queued, causing performance issues. The engineer must balance the load evenly across all nodes without increasing the cluster size. How can you do that? In Redshift, when data is unevenly distributed across nodes, which is when one node, which is the hot node because too much traffic, becomes a bottleneck, leading to skewed CPU usage and slower queries. Choosing a high cardinality column as the distribution key ensures data is spread more evenly among all compute nodes. High cardinality means unique data. This balances workload distribution during query execution and eliminates queuing on a single node, improving overall cluster performance without resizing. A security company stores IoT JSON data in S3 bucket. The data structure changes when devices are upgraded. The analytics team needs a cost-effective data catalog that automatically adapts to schema changes and supports downstream exploration and indexing. Again, Glue Data Catalog, which provides centralized metadata repository that works with Athena, EMR, Redshift Spectrum. Then we have Glue Schema Registry, which handles schema evolution automatically, tracking and validating changing data structures in streaming or batch pipelines. Together, they enable the analytics department to easily index and query IoT data without manual schema updates or cluster management, offering a serverless and cost-effective solution. A data engineer manages S3 bucket that stores transaction data. The company needs to log every write operation, such as uploads, deletions, or modifications made to this transactions bucket. The logs must be automatically stored in another S3 bucket within the same region. The solution should require minimal setup and management overhead. How will you do that? It's very simple. CloudTrail, it records all data level API operations, for example, like put operation, delete operation, etc., on S3 buckets when data events are enabled. By configuring a CloudTrail trail to monitor data events specifically for the transactions bucket, every write is logged automatically and stored in another S3 bucket. This solution provides fine-grained auditable logs without requiring Lambda or Firehose or custom scripts, making it the simplest and most approachable solution. A company runs analytics workloads using EMR and Athena. The team maintains multiple tables across systems, and some of their metadata currently resides in Hive. A data engineer must create a central metadata repository. Sitha, should I continue more? As soon as you see central metadata repository, you already know the answer. That both EMR and Athena can query while minimizing development and integration effort. I think you know the answer. And metadata from an existing Hive metastore can be imported directly into Glue. How? Using Glue import catalog. Or you can use EMR Hive's configuration. In the Hive configuration file, there will be a property called hive metastore glue catalog, put it as true. Then it will actually in the Spark masterclass video, we actually use PostgreSQL database as the EMR hive to store the hive as the metastore. You can check this, not glue metastore, but you will check that metastore property there, which is kind of similar. A company, uh, a data engineer in a company is designing a data lake on S3. Multiple analytics teams will access the same data sets using Athena, Redshift, Spectrum, EMR. The company requires row level and column level. Sita Pragnas, as soon as you see row level, column level access, what is the answer? Yes, that is correct. Lake formation. I don't think I need to explain it. Do I? A data engineer manages CSV files in S3 containing flight metrics for a proof of concept analytics project. The data is partitioned by date and queried using Athena. As the data set grows, Athena queries slow down and the company needs to optimize storage for better. You know the answer. CSV files? Nope. Then Parquet. That's the answer. A data engineer manages a write-heavy Amazon RDS for MySQL database that powers a mission-critical application. Recently, the database CPU utilization has spiked, leading to application slowdowns. The engineer needs to lower CPU usage while maintaining database performance and stability. How can you take care of this? Well, we are going to use performance insights. This helps pinpoint SQL statements or stored procedures that consume the most CPU time, allowing query tuning or index optimization to alleviate your load. If query optimization doesn't fully resolve the issue, scaling the DB instance class, for example, let's assume from M6G large to M6GX large, which increases available CPUs and memory, directly reducing CPU contention. This combination targets both software level inefficiencies via query tuning and hardware level constraints via scaling. A data engineer manages Redshift table, which is orders, that has been used for 6 months. The table undergoes frequent updates and deletes. It uses an interleaved sort key on the AWS region column. The engineer needs to reclaim disk space and optimize sort key performance to prevent storage issues and maintain query speed. In Redshift, frequent updates and deletes can fragment data blocks and distort interleaved sort keys, leading to wasted space and slower queries, which happened to us after we introduced Redshift. Previously, it was on SQL Server, then we moved it to Redshift, and after an year or so, we started seeing slowness, etc. This is back in 2019-ish, I guess. So we had to involve the AWS team. Somebody came over, then they checked everything, and then they decided you guys are not running vacuum. The vacuum reindex operation is specifically designed for tables with interleaved hotkeys as it rebuilds the index and reclaims unused storage. Unlike vacuum full, which rewrites all rows, or vacuum delete only, which only removes deleted rows, vacuum reindex efficiently restores sorting and improves scan performance on the sort key column. If you don't know what vacuum is, I would recommend you to check the documentation. But basically what it does is whenever you delete a record, and even if you perform an update on Redshift, it's not technically an update. Behind the scenes, Redshift, what it does is it will delete and insert it. Okay, so when you delete a row, it's soft deleted so that we don't see it, but behind the scenes it will still be there in the database until you run the vacuum command. So now then once we got that issue, then we scheduled a job that actually runs the vacuum I think every day at some time. I don't remember, but yeah. A manufacturing company needs to collect IoT sensor data in near real time. The data must be stored persistently in nested JSON format, and queries on this data must have latency under 10 milliseconds. The data engineer needs to build this ingestion and query solution with minimal operational overhead. How can you do that? All right. So we are going to use Kinesis data streams. Why? Because it provides scalable, fault tolerant stream ingestion pipeline capable of handling high throughput IoT data in near real time. Since we are looking for under 10 milliseconds, this is the only thing that can provide you to consume IoT data. The captured data can be written to DynamoDB, which supports millisecond level read write latency as well as JSON document storage natively. This setup avoids managing servers or databases and ensures consistent low latency access to structured sensor data. Already again it's been an hour, so I would recommend you to take a break, uh, take a walk, go have some water, walk for 5 minutes, have some fresh air, then see you soon. Welcome back after the break. Let's continue with the exam study guide. We just scratched the surface. We have plenty of questions to go, and I know I'm taking a lot and lot of time to cover these scenarios. So let's increase the speed, shall we? Because we pretty much covered more, not at least half of the topics we covered. So repeating topic, I will move faster. And if you haven't got a chance to subscribe, like, and comment, please do that. That will really help this channel and the video to be displayed in the search results. A data engineer makes a data lake on S3 containing raw data with personally identifiable information, or PII in short. Multiple user groups across departments need to query the data, but they should only see specific PII columns relevant to their access level. The engineer must enforce this fine-grained access control with the least manual effort. So let's say the CEO should be able to see anybody's date of birth and etc., whereas the lowest level should only see their first name, not even the last name, kind of thing. And we already discussed data lake plus fine grained access is equal to the pregnance lake formation. A data engineer must build an ETL pipeline that ingests files from 10 source systems every 15 minutes. The files, which are in CSV, JSON, Parquet formats, are delivered to a single S3 bucket, and they range from 10 MB to 20 GB. Processed data must be loaded in 10 Redshift tables, and the pipeline should handle schema changes automatically without breaking the flow. How are you going to design such a solution? Well, the solution, as you have seen, combines the automation and resiliency of glue workflows with event bridge scheduling and triggers. So this is how we are going to do it. An event bridge rule runs every 15 minutes to invoke the glue workflow. Then the glue workflow first runs on-demand glue crawler. Why? Because we need to detect schema changes dynamically across the incoming files. Once the crawler completes successfully, the ETL job runs automatically to process the data and load it into Redshift. This pattern handles new or modified schemas without manual intervention and scales seamlessly for multi-source ingestion. A financial company uses Athena to query petabyte scale dataset stored in S3. The dataset is updated once daily by a glue job, but the BI application refreshes it or refreshes the data every hour. The company needs to reduce Athena costs while maintaining freshness and avoid adding extra infrastructure, for example, caches or clusters. How are you going to implement this without adding anything extra? Well, you need to use a feature. What is that feature? It's called with query result reuse. Athena stores the output of previous query executions. When a subsequent query runs and matches a cached query's text and inputs, Athena retrieves the previous result set instead of scanning S3 again. This feature exists in Snowflake as well. I don't know who copied from where. Since the dataset changes only once per day, all queries within the same day can reuse cached results, cutting costs drastically while maintaining near instant responses for hourly BI refreshes. A data engineer manages Redshift cluster with strict budget limits, meaning the cluster cannot be resized. The cluster hosts multiple tables. Some are hundreds of GB, while others are less than 10 MB. The engineer needs to improve query performance without increasing computer storage costs. How can you do that? Well, that's why we have a couple of features on Redshift tables. One of them is distribution key. So in Redshift, performance optimization depends heavily on data distribution and sorting rather than raw cluster size. By carefully assigning these keys, first one, distribution keys, which ensure related data. For example, joining columns, the columns that you use to join, right? They are co-located on the same node, reducing costly data shuffles, right? If the columns that you use to join, if they all exist on the same nodes for different tables, you don't have to bring data from one table to another table to do the join or shuffle, right? So that's distribution keys advantage. Then you have sort key, which helps you prune unnecessary blocks during query scans, improving IO efficiency. What does that mean? Prune means what? Remove. Since data is sorted, let's assume that there is a date column. You put a filter saying um, some time step greater than 2025. Since data is sorted and you are using the sort key, it knows 2025 above and 2025 below. So it won't even scan 2024 data and below data. It will only scan the 2025 data. So that's kind of like pruning the blocks. And finally, partitioning. Using automatic table partitioning or materialized views, doesn't matter. This can further reduce the scan size for time series or range based queries. Meanwhile, smaller lookup tables can use all or dist style auto to this is for the distribution, by the way. There are different distribution styles you can mention. So you mentioned this for smaller lookup tables to replicate them to every node, minimizing joins with larger tables. This strategy maximizes the current cluster's performance without scaling any hardware. A data engineer receives CSV files containing physical address data with columns such as door number, street name, city, and zip code. The engineer needs to combine these fields into a single JSON style column. Let's assume with a JSON structure, you have door number, then something, and then street name, ABCD, city, and zip code. The solution must be implemented with least coding effort. How can you do that? Well, least coding means try to use data brew because it's drag and drop, which is a visual data preparation tool that lets data engineers and analysts clean, transform, and enrich data without writing any code. The nest to map transformation allows grouping multiple related columns into a single map structured column, which is nothing but the key value pairs that represents JSON like data. In our case, the engineer can select the four address fields, which are door number, street name, city, and zip code, and nest them into one map column. This transformation automatically creates a new column with a JSON like structure, no Python or custom ETL scripting required. A company receives call logs containing sensitive customer information in S3, and they must encrypt the S3 objects to ensure data confidentiality, use encryption keys accessible only to specific employees, implement the solution with least operational effort. So, whenever you hear the word encryption, you will think of KMS. And in this case, we are going to go with SSC KMS, which is the best balance between security, simplicity, and control. Why? Because SSC, Amazon S3 is provided by Amazon S3, which automatically encrypts data at rest using KMS key. You can use key policies and IAM permissions to specify exactly which employees can encrypt or decrypt data with the KMS key. You don't have to modify or manage encryption code at all. S3 integrates natively with KMS, and AWS handles key rotation and auditing via CloudTrail. You are not going to go with SSC S3, which is what by default S3 provides, because these lack fine-grained access control. Or if you are going to use SSC C, it requires manual key management, increasing operational overhead. You cannot rotate keys and whatnot. So, whereas with this, you can. A company stores petabytes of data across thousands of S3 buckets in the S3 standard class. And the access patterns are unpredictable and variable. Some data is untouched for months, yet must remain millisecond retrievable. The company needs to optimize costs with minimal management overhead. How are you going to do that? Whenever you see the word unpredictable in the question when you are writing the exam, immediately go for S3 intelligence steering, because that class automatically moves data between frequent and infrequent access tiers based on actual usage. Since we don't know the pattern, it can figure it out on its own, which means no manual lifecycle rules required. This is designed exactly for unpredictable or changing access patterns. It automatically monitors and transitions objects between tiers to minimize cost. It keeps all data instantly retrievable, milliseconds. Unlike Glacier tiers, requires no performance impact or reconfiguration of applications. The default access tier without the deep archive balances cost and retrieval speed perfectly. During a security review, a company discovered that an AWS glue job had hard-coded credentials to connect to Redshift cluster. The data engineer must remove the vulnerability and ensure credentials are securely stored and accessed without embedding them in a code. This reminds me something that I identified recently in one of the Lambda function, not too long ago, like 2 weeks ago. So I noticed that one of the Lambda function, it actually is printing production password to the database. So I informed, and then what did I do? I removed them. The Lambda was already getting the credentials from secret manager. In this case, that's not the case. In this case, they hard coded the password, but in our case, we are printing the password, even though we are getting it from secrets manager. Anyways, here the answer is what? Hard coding credentials violates AWS security best practices. The right approach is to use Secrets Manager, which securely stores, rotates, and encrypts sensitive credentials like database, username, and password. Okay, so you first step is store credentials like Redshift username and password in AWS Secrets Manager. And then you attach an IAM policy to the glue jobs IAM role that grants it access to get the secret from the secrets manager. And finally, in AWS glue script, you retrieve the credentials dynamically using the Boto3 client or the built-in glue connection to secrets manager, whatever the case. A data engineer manually creates and deletes the Redshift provisioned cluster each month to run resource intensive analytics. After processing, they unload backups to S3 and delete the cluster. As you can see, this is a repetitive and manual process. Now they need a hands-off, cost-efficient solution that eliminates infrastructure management. It is very easy. If you want Redshift, but if you don't want to manage the infrastructure, just go with the serverless version of it, which eliminates the need to create, resize, or delete clusters. It automatically provisions and scales compute capacity based on workload demand, making it perfect for infrequent but heavy workloads like monthly analytics runs. What are the key benefits? Well, no manual provisioning or deletion, fully managed. Pay only for compute used during query execution, and you can instantly resume from S3 based storage. And finally, it's fully compatible with SQL scripts and existing Redshift data pipelines. So when you compare this to provisioned clusters, this approach offers both operational simplicity, cost savings, since billing stops when queries finish. A company receives a daily .xls or Excel customer data file, which is approximately 2 GB in size, in S3 bucket. The file contains separate columns for first name and last name. The data engineer must concatenate these columns and determine the number of distinct customers while minimizing operational effort or while minimizing the effort. If you want to minimize the effort, don't code, just use Databro. This provides no code interface for cleaning, transforming, and analyzing data stored in S3 or other data sources. The data engineer can connect Databrew to S3 location containing the Excel file, then create a new column using a Databrew transformation that concatenates both the columns, and then apply the distinct count aggregate function to calculate unique customer counts. This approach avoids coding or cluster management as needed in EMR or Glue Spark jobs. Databrew automatically handles the Excel format and scaling for 2 GB datasets. A healthcare company streams real-time health data from wearables and hospital equipment via Kinesis data streams. They need to store the data in Redshift serverless, support near real-time analytics that combine live data and previous day's data, and you need to minimize overhead. How are you going to do that? You have streaming data. Well, Redshift has something called Redshift Streaming Ingestion. This feature allows direct ingestion from Kinesis data streams or Amazon MSK into Redshift tables without staging data in S3 or using copy command. This capability or feature provides near real-time ingestions, just seconds delay, continuous data availability for queries, automatic scaling via Redshift serverless, and finally, no need for ETL orchestration, Kinesis Firehose or Lambda transformations. The previous day's data can reside in standard Redshift tables, while the streaming data continuously updates live tables for immediate analytics. A data engineer is accessing an QuickSight dashboard that uses Athena queries on data stored in S3. When connecting, the data engineer encounters insufficient permissions errors. You must identify which permission related issues could cause this. Name some that you think top of your mind. Well, when QuickSight queries data through Athena, it requires permissions at different levels. One, since you are using Athena, you need access to S3, right? QuickSight must be able to read both the source data as well as the query results bucket that Athena uses. So if the IAM role or S3 bucket policy doesn't grant get object or list object, the dashboard query will fail. That's one of the reason. And the second reason, if objects are encrypted with KMS managed keys, QuickSight's IAM role must have the decrypt permissions for that KMS key. Missing either of these permissions leads to the insufficient permissions error. A company has data in multiple sources. You have JSON and CSV files in S3, and then you have relational data in RDS for SQL Server. You have NoSQL data in DynamoDB. Finally, analytical data in Redshift. Data scientists need to query all these sources with SQL-like syntax with minimal operational overhead. How can you do that? I think we discussed one similar to this, didn't we? Athena has a feature, right? But yeah, what was that approach or the feature of Athena? It's called Athena Federated Query. So we are combining that capability of Athena with Glue data catalog as a unified metadata layer. Okay, and the first thing that we do is crawlers. They automatically infer the schema and they populate the data catalog for S3, RDS, DynamoDB. Then Athena can query all data sources using SQL syntax using standard SQL for RDS and Redshift, particular for semi-structured JSON data. Here, as you can see, no cluster setups, no ETL pipelines, or no data movement is required because Athena reads directly from the sources. This solution is serverless, cost efficient, and requires no infrastructure management compared to EMR or manual transformation workflows. A data engineer is using SageMaker Studio to launch AWS Glue interactive sessions for preparing ML model data. When attempting to prepare data, the engineer receives an access denied error. The goal is to determine which change will correctly grant access between SageMaker Studio and AWS Glue. SageMaker Studio, it can initiate AWS Glue interactive sessions. But this cross-service interaction requires IAM role assumption via AWS Security Token Service, in short STS. To allow this, the data engineer's IAM user must have permission to assume the AWS Glue role and a trust relationship. I mean, this is kind of cross account access, right? You need permission to assume the role, and second, trust relationship that includes the Glue Amazon AWS.com and the SageMaker Amazon AWS.com. Without this, SageMaker cannot initiate the Glue session on behalf of the user. This configuration allows SageMaker to spin up Glue interactive sessions securely without manually provisioning compute or credentials. A company extracts 1 TB data daily from diverse sources like SAP, HANA, SQL Server, MongoDB, Kafka, and DynamoDB. Some sources have undefined or evolving schemas. The company must detect schemas automatically, perform ETL, load data into Amazon S3 within 15 minutes of data creation with minimal operational overhead. I think you know how you can get the evolving schemas, right? How can you do that? Well, let's use AWS Glue first of all, which is a serverless ETL service that can auto detect schemas using crawlers. Right? So what does the setup look like? You will use Glue crawlers to detect and catalog schemas dynamically, even if they evolve. And then you are going to use Glue connectors to read data from multiple sources. Those include SAP HANA, SQL Server, MongoDB, DynamoDB, and Kafka. Then you will build a Spark based Glue job to perform transformations and write output to S3. And then you will schedule these jobs or do you trigger them via event bridge to meet the 15-minute SLA. This provides serverless orchestration, schema inference, and parallelized Spark processing, all managed by AWS. A company stores datasets in S3 used by multiple applications. One of them, an e-commerce app that contains PII, and then an internal analytics app that doesn't require PII. The company must comply with data privacy regulations and redact PII dynamically based on each application's needs without maintaining multiple dataset copies. How can you do that? Since you don't have to maintain multiple copies, you have to read it from one copy. That's why there is an option on S3 which is called Object Lambda. This will allow developers to add custom processing logic when you are reading objects from S3. How crazy is that? So when you try to read from S3, it will trigger a lambda which will run your custom code. Can you imagine? This was initially there on, I think, Firehose, similar one. And now you have it here. I mean, it's been a while, but I'm just telling you. So this doesn't change the underlying data at all. It reads the data, then applies the transformation on the fly. This is how it works. If you don't know, just in case. The original data set with the PII stays securely stored in S3. Each application accesses data through S3 object lambda access point. The lambda function attached to that endpoint determines the context. For example, the application type or IAM role, and dynamically it returns full data for authorized apps like e-commerce and redacts or masks PII for analytical apps. This approach ensures a single source of truth and dynamic redaction at retrieval time with no need for multiple copies or periodic data refresh. Users upload small CSV files which are less than 100 MB daily to S3 bucket. A data engineer needs to build an ETL job to process these files daily in a cost-effective and simple manner. How do you do that? For small data volumes like less than 1 GB, spinning up a Spark-based AWS Glue job or an EMR cluster adds unnecessary cost and latency. Instead, just use Glue Python shell jobs. They run a single Python script environment which is lightweight, serverless, and inexpensive. The engineer can use pandas or pyarrow to perform transformations, read input CSVs from S3 and write processed output back to S3, and schedule the job via event bridge or glue triggers. Since glue shell jobs use minimal resources and execute quickly, they are the most cost-effective ETL choice for small batch-style data. A data engineer has glue data catalog table named orders created by a glue crawler. The engineer needs to add two partitions located in S3, something like S3 transactions, orders, and then you have partition as order date, which is equal to 2023-0101, and similar one, but with another partition 2023, I mean like same partition, which is the order date. The partitions must be added manually without rescanning all existing S3 folders or rerunning the glue crawler. How can you do that? Remember, I told you two methods how you can add the partitions. One is using the MSCK repair. But if you do MSCK repair, what does it do? It scans all the S3 folders, right? You can use the glue crawler, but you question clearly mentioned you should not use it. So how do you do it? The other method that I mentioned, which is the manual method, which is add partition. This command. Okay, alter table, add partition. This DDL command in Athena, which uses glue data catalog, allows you to manually register specific partitions. This method directly updates the metadata in the glue catalog. It avoids a full scan or rerunning the crawler, ideal when new partitions are known ahead of time. The command is lightweight, executes almost instantly, updating only the specified partitions. A company stores 10 to 15 TB of uncompressed CSV files in S3 and plans to query them with Athena. They want to reduce query runtime and minimize storage costs through format and compression optimizations. You already know the answer. CSVs, if you want to optimize, it's Parquet with Snappy. They go hand in hand. Parquet is columnar storage format, ideal for analytical queries and Athena optimization. When paired with Snappy compression, it provides high compression ratio, which reduces S3 storage costs. Column pruning, which reads only the queried columns, minimizing data scan. It provides splittable files, which improves parallel query performance. And finally, its native support with Athena and Glow. By converting raw CSV files to Parquet with Snappy, queries can become 10 to 50 times faster and up to 90% cheaper due to less data scanned. A company currently uses Apache Airflow on premises to orchestrate data pipelines. These pipelines include SQL based data quality checks. The company wants to migrate to AWS managed services while keeping refactoring minimal and continuing to use Airflow orchestration. It's very simple. They clearly mentioned they want to use Airflow on AWS. So we have something called MWAA or Amazon Managed Workflows for Apache Airflow. This is a fully managed Apache Airflow service built to allow seamless migration from self-managed Airflow setups to AWS. This uses the same DAG structure, operators, and code base as on-prem Airflow. It requires no major code rewrite. You might need to do some low refactoring, but no recoding. Integrates natively with AWS services like Glue, Redshift, Athena, and S3. And it supports SQL operators and sensors, allowing existing SQL data quality checks to run as is. So if you were to migrate, what are the things you need to do? You export your DAGs, plugins, and Python dependencies, then import them into MWAA via S3 DAGs folder. And finally, point MWAA to your data sources and AWS services. That's it. A company uses EMR to run ETL pipelines from multiple data sources. A data engineer must orchestrate these EMR jobs to maximize performance while keeping costs low. And who is our hero here? Step functions. This provides serverless orchestration for complex ETL pipelines and integrates natively with EMR. Why is this the most cost effective though? Because step functions automatically handles job sequencing, retries, and parallel execution. You only pay per state transition, no infrastructure or scheduler to maintain. Easily integrates with EMR start job flow and add step APIs. It can parallelize extract transform stages for maximum throughput. So how would a typical architecture pattern look like? You start your EMR, or you can use transient cluster mode. Then you add ETL steps. For example, like is it Spark, Hive, Presto. Then you wait for a completion or handle errors via built-in retry logic. Finally, you terminate the cluster. When done, to save cost. An online retailer stores ALB access logs in S3 and queries them with Athena. As the data grows, queries slow down because the table is unpartitioned and metadata isn't kept up to date. How can you make the metadata up to date and make the queries faster? Well, as soon as you hear the word metadata and update, you know the answer. First, ALB logs are naturally partitioned by path, if you don't know that. Right? Region, year, month, day. A glue crawler, that is what you should remember when you think of metadata update. It discovers schema and partitions and updates the data catalog so Athena can prune data during queries. This reduces scanned data, improves performance, and requires minimal maintenance. Easy peasy lemon squeezy. A company transfers files via S3 file gateway and needs an automated way to start a multi-job glue workflow immediately after each successful transfer. How can you do that? Well, S3 file gateway, it emits events. Pretty much every service emits events. And this one emits events on successful transfers that event bridge can match. The rule invokes the glue workflow directly, providing a serverless event driven trigger with no polling, no cron jobs, or no manual steps. A retail company uses Aurora PostgreSQL for transactions and Redshift for analytics. The company wants to reduce Redshift storage costs by archiving historical data, but it must still be able to query live data in PostgreSQL, current data in Redshift, and archive data in S3. Only the latest 15 months should remain in Redshift. How can you do that? Well, you have something called Redshift Federated Query. This feature allows Redshift users to directly query live data in Aurora PostgreSQL without data movement, which means you don't have to bring the data to Redshift. You can still query it. For cost optimization, older data can be periodically unloaded from Redshift to S3 using the unload command and queried using Redshift Spectrum. This architecture combines all three data sources: Aurora, which is live, Redshift, which is current, S3, which is archived, while minimizing Redshift storage costs. A manufacturing company's IoT devices send data to Kinesis data streams using facility ID as the partition key. Some shards experience very high write traffic while others stay idle, causing write throughput exceeded errors. All right, so how do you handle this then? So we use a static partition key like facility ID. Using such a key can lead to uneven traffic distribution because all data from same facility lands in the same shard. That's why a random or more granular partition key, such as combining facility ID with a timestamp or random suffix, distributes records evenly across shards. This avoids hot shards and improves throughput without requiring unnecessary shard scaling. A data engineer wants to analyze the performance of SQL queries running in Athena by examining their execution plans and understanding the computational cost of each operation within a query. If you want to understand all this, all you need to do is try, explain, analyze. Command. This is together, not just explain. This command in Athena executes the query and provides detailed runtime statistics, including the execution plan, operator level cost, and amount of data processed. This helps identify inefficient operations such as full table scans, expensive joins, or unnecessary shuffles. The regular explain statement alone, by contrast, provides a static plan without cost or runtime metrics. That's why executing this entire thing is important. A company configured VPC flow logs to publish to CloudWatch logs and needs to send these logs to Splunk in near real time while minimizing operational complexity. How can you do that? Well, that's where our Kinesis Firehose comes into picture, because this provides a fully managed serverless data delivery mechanism that can directly integrate with Splunk's HTTP event collector, or HEC in short, endpoint. When combined with a CloudWatch log subscription filter, flow logs are streamed in near real time to Splunk without the need for custom code or Lambda functions. This architecture minimizes maintenance and ensures reliable delivery with automatic retry and buffering. A company's data lake on S3 uses Glue Data Catalog and Athena for querying. Duh. The company wants to control access at column level. Sithapragnas. We don't even need to finish this question or scenario, right? As soon as you say row level, column level access, that's it. Based on user roles, ensuring that data scientists and analysts only see the columns relevant to their responsibilities, and no surprises here. A company runs AWS Glue ETL jobs daily to process S3 data and load it into RDS for MySQL. Currently, all files in S3 bucket are processed each day, and the company wants to modify the jobs to handle only new or updated data since last run. How can you do that? In Glue, well, you have a feature called job bookmarks. This maintains state information about previously processed data sources such as files in S3. When enabled, Glue automatically skips data that has already been processed in prior runs, allowing the ETL job to handle only new or changed files without any additional code. This minimizes development effort and improves performance by reducing redundant reads. An online retailer needs to collect VPC flow logs and analyze network traffic while keeping storage and query costs low. Writing flow logs to S3 avoids CloudWatch's ingestion or retention costs. Storing data in Parquet drastically reduces storage size and the amount of data Athena scans, cutting query costs and improving performance. Then Athena can directly query the Parquet data in S3 without running servers, meeting the analytics need cost effectively. A retailer's Redshift cluster frequently broadcasts a small, rarely updated store location table to all nodes, slowing queues and queries. The goal is to reduce broadcast overhead cost effectively. How can you do that? With event distribution, Redshift must broadcast small dimension tables during joins, adding network overhead. Dist style all replicates the small infrequently changes or changed store location table to every node, eliminating repeated broadcasts and accelerating joins. Because the table is small and rarely updated, the replication overhead is minimal and cheaper than scaling the cluster. A Redshift table sales includes a city name column. You need all rows where the city begins with SAN or L. I think this is more of a SQL question. So in order to do this, we are going to use the tilde operator, which matches POSIX regular expressions, and the caret anchors the pattern to the start of the string. If you don't know regex, this is start and this is end in regex. And so when you write it something like this, you are telling this is what, like it's a like where regex, and then this means it should start when you put in brackets and this is R, it checks for either of them, and then you are saying star. Okay, so this pattern ensures only city names beginning with SAN or L are returned. And you know this pipe symbol is alteration like R. DMS is streaming changes from on-prem Postgre to Redshift. The task shows high CDC latency and you need to confirm whether the source database is causing the delay. How can you do that? Well, there is something called CDC latency source measures the time difference between when a change was committed on the source and when DMS read it from the source's logs. A high value indicates the latency originates at the source, for example, WL availability, IO contention, replication slots, etc. Metrics like CDC incoming changes, they show volume, they do not show latency attribution. This is what shows the latency. IoT sensors emit approximately 100 kb every 10 seconds. A downstream job reads from S3 every 30 seconds. The pipeline must deliver data in S3 with minimal end-to-end latency. Firehose to S3, Firehose can directly write to S3, has a minimum buffer interval of approximately 60 seconds, which is too high for sub 30 second that we need. So you cannot use that, right? Whereas a custom KCL consumer on Kinesis data streams can flush small batches, example every 5 seconds, directly to S3, providing lower latency while preserving ordered scalable ingestion. No cluster is required. Buffering logic is fully controllable in the app. Company needs daily transformations on 300 GB arriving on a schedule and a one-time processing run on terabytes of archive data in S3, all orchestrated by MWAA. The first thing that you do is glue crawlers. They automatically infer and register evolving schemas in data catalog with minimal code or ops. Amazon EMR provides scalable, cost efficient Spark processing for both the 300 GB daily workload and terabyte scale historical runs. And then ephemeral or auto terminating clusters and spot instances, they can further reduce cost. And MWAA or Airflow DAGs coordinate the crawler runs and EMR steps in a repeatable workflow. So Glue plus EMR Spark plus MWAA. A retail company runs Glue ETL on customer orders and needs to enforce specific validation rules to guarantee accuracy and consistency before loading. Glue data quality lets you author something called rule sets. For example, null checks, ranges, rejects, uniqueness, referential integrity. These are some of the rule sets and apply them in ETL jobs. Failing records can be quarantined or flagged and metrics are emitted for monitoring. Custom rule sets precisely encode business logic that generic transforms or bookmarks can't enforce. An insurance company stores ZZip compressed transaction data and needs an occasional low cost way to run audit queries. We are going to use Athena, which is effective for cost effective for ad hoc queries. You pay only for data scanned. It can read gzip compressed files in common text formats like CSV or JSON. While gzip isn't splittable, which affects parallelism, it's fine for occasional audits and avoids provisioning databases or clusters. A team tested a non-mission critical Redshift stored procedure and needs it to run automatically every day with minimal cost and setup cost. How? Well, we checked this option a while ago, right? Redshift query editor, which lets you create scheduled executions without provisioning compute outside Redshift. You can call the stored procedure on a cron like schedule, monitor runs, avoid managing Lambda. Glue jobs are easy to just to trigger SQL. This is the lightest weight and most cost effective option for simply daily automation. Clickstream data lands in S3 via Firehose. Hundreds of users need QuickSight dashboards with daily refreshes that scale cost effectively. Again, Athena, which provides serverless SQL over S3, eliminating cluster costs and scaling automatically for variable workloads. QuickSight Spice This caches results in an in-memory engine for fast concurrent dashboard access. Scheduling a daily refresh keeps data current while minimizing per query costs and pressure on Athena. We have done, I think, 3 4 projects where we used QuickSight Spice and connected to Athena in our projects playlist. Data engineer needs to build a hybrid orchestration workflow using both on-premises and cloud resources while maintaining portability and preferring open source technologies. And there is only one option, you already know that, which is the MWAA, which provides a fully managed version of open source Apache Airflow orchestration engine. Airflow can also be deployed on premises, allowing seamless workflow portability between environments. This ensures consistent DAG logic, scheduling, and dependency management, whether running locally or in AWS without vendor lock-in. A gaming company needs a fully managed, globally available NoSQL database with single digit millisecond latency for high throughputs. There is only one service that can give you single digit millisecond latency, and that is DynamoDB. This is a fully managed NoSQL service designed for massive scale and high performance workloads. It delivers single digit millisecond latency at any scale and supports global tables for multi region replication and high availability with minimal configuration. It requires no server management, indexes, or patching, making it ideal for OLTP use cases. A data engineer configured an event bridge role to invoke a Lambda function, but the invocation fails with access denied exception error. We have seen a similar question, the Pragnas, you should know the answer. Event bridge requires permission to invoke the Lambda function, which is granted through Lambda resource based policy. So you have something like this. In addition, the IAM role that event bridge uses must be allowed to perform the action. Ensuring both policies are properly configured enables secure authorized invocation between event bridge and Lambda. The company must meet compliance requirements mandating 2 layers of server-side encryption for data stored in S3. The solution must use AWS native capabilities, possibly triggered by Lambda. DSSEKMS, dual layer server side encryption, automatically applies 2 independent layer of encryption using AWS KMS managed keys for each object uploaded to S3. This feature provides regulatory grade protection without needing custom Lambda logic or client side encryption. It's natively managed by S3 and ensures that both encryption layers are distinct and independently managed. A data engineer observes that Athena queries are delayed and remain in a queue before execution begins, indicating that concurrent query capacity has been reached. How do you deal with such situation? By default, Athena uses shared query capacity, which can result in queuing during heavy usage. Provisioned capacity, it dedicates a fixed number of data processing units or DPUs to a work group, ensuring predictable performance and eliminating query waiting time. This approach is ideal for production workloads that require consistent response times or handle many concurrent users. A glue job reads from S3 and writes to Redshift with bookmarks enabled, but it still reprocesses previously loaded files during later runs. Didn't we learn we use bookmarks because we don't want to process already processed data? Well, let's learn how bookmarks actually work, right? Bookmarks track which S3 data has been processed by recording job state after successful commits. If the ETL script omits a job commit call, the bookmark state is never saved. causing glue to treat all files as new in each run. This leads to unnecessary reprocessing. Adding job.commit ensures the bookmark metadata is updated after each successful job completion. An e-commerce company wants to migrate its on-prem data pipelines to AWS. The pipelines currently use a third-party orchestrator to run Python and Bash scripts, and the new solution must be serverless, require no refactoring, and minimize operational overhead. You already know the answer. We are going to use Apache Airflow, which allows you to run existing DAGs and operators, including Python and Bash operators, without modifying the original scripts. The retail company wants near real-time insights from its on-prem MySQL PLM database integrated with other datasets in Redshift. A direct connect link already exists, and you need minimal development effort to do this. So we are going to go with the DMS, which can perform initial full load and then capture ongoing changes from MySQL transaction logs to keep Redshift in near real time. This eliminates the need for complex custom ETL jobs or connectors, and it's fully managed, handling schema mapping, retries, and incremental sync automatically. So let's take another break here. It's almost an hour. So go walk for 5 minutes and see you soon. Welcome back. Here we are. A marketing company stores clickstream data in S3 across multiple buckets and runs daily SQL joins. They need a serverless, cost effective way to partition data for faster queries while maintaining ACID guarantees. Thethabragnas, do you remember? If you want ACID properties on your S3, what should you do? We will go ahead and we'll use Athena because it's serverless and it's cost efficient for ad hoc and scheduled analytics on S3. By defining partition tables in Glue and using ACID table format like iceberg. If you want ACID complaints on your S3, then you should go with a format something like iceberg. Athena supports reliable inserts, updates, deletes, and transactional reads while enabling efficient joins across buckets. This avoids maintaining or managing clusters and keeps costs tied to data scanned. So, a combination of these two and Apache Iceberg tables to preserve ACID guarantees on S3. Data must be migrated from RDS to PostgreSQL, which is in this particular region, to Redshift in this particular region. Okay, with DMS. And the replication instance needs network access to both the endpoints, correct? Of course, you need to do that. So, what do we do? By placing the replication instance in the target account or region. What is our target? Which is the Redshift. Simplifies security and minimizes target side latency and data transfer in the destination region. Luckily, DMS supports cross-region and cross-account replication. The instance can securely connect to the source RDS in another region via public endpoints or private networking, either using VPC peering or transit gateway, while writing to Redshift locally. For that reason, we will have this in here in this region. Data files are organized by source in S3 and loaded into one Redshift table by issuing a separate copy command per S3 path, which is very slow. The company wants faster ingestion without adding costs. Well, you can do that using something called manifest file, which lets Redshift parallelize reads across many S3 objects, and prefixes in one copy, eliminating per path overhead and improving throughput. It requires no extra infrastructure or services, so it accelerates loads at the same cost profile as before. Source data arrives as 2 MB CSV files. The pipeline must convert CSV to JSON and store the data in S3 as Parquet with minimal development effort. How can you do that? Firehose provides managed record format conversion and delivery to S3 by default. With built-in conversion, you can transform incoming CSV to JSON and then output as Parquet without writing any custom code or standing up processing clusters, which minimizes build and ops work. So you can achieve all that using Kinesis Data Firehose. A company uses AWS Transfer Family Server to migrate on-prem data to AWS and must comply with a policy requiring TLS 1.2 or higher for all in-transit compliance or encryption. Luckily, Transfer Family lets you define a security policy that controls allowed cipher suites and protocol versions of SFTP, FTPS, or FTP over TLS connections. By specifying TLS 1.2 as the minimum requirement, you ensure that all clients connect securely using only compliant encryption standards without modifying SSH keys or network configurations. A company wants to migrate an on-prem Apache Kafka setup to AWS using a replatform approach. Replatform is not refactoring, minimizing management burden while continuing to handle Oracle database change streams. Again, we are going to go with MSK serverless, which delivers a fully managed auto scaling Kafka environment without provisioning brokers or storage. It provides the same APIs and compatibility as open source Kafka, making migration straightforward, which means replatform, not rewritten. This eliminates cluster capacity management, patching, and monitoring while maintaining Kafka streaming semantics for incremental updates. A data engineer is developing an automated AWS Glue ETL pipeline that ingests compressed files from S3. The pipeline must handle incremental data processing to avoid reprocessing previously loaded files. This is a pregnancy. We have learned this concept. What is it? It's called bookmarks in AWS Glue job. What does this do? This tracks the state of previously processed data sources such as S3 files by recording metadata about the last successful job run. When enabled, Glue automatically skips files already processed in earlier runs, allowing efficient incremental ingestion with no extra coding or configuration changes. A banking company sends high volume transactional data via Kinesis data streams using put record. Occasional network outages cause duplicate records, and the company requires exactly once delivery across the pipeline. Kinesis data streams guarantees at least once delivery. So duplicates can occur under retry conditions. To achieve effective exactly once semantics, the producing application must assign a unique identifier, for example, like a UUID or composite transaction key to each event. And then the downstream consumers like Flink or Lambda can use this ID to deduplicate records idempotently during processing. Okay, this is the key here. Kinesis by default provides at least once delivery. A data engineer found that several log files in S3 bucket were unintentionally deleted and needs a way to prevent future accidental deletions with minimal maintenance effort. How can you avoid it? Simply by using S3 versioning. This keeps multiple versions of an object whenever it's modified or deleted. If a file is accidentally deleted, you can easily recover the previous version through the S3 console or the API. Enabling versioning requires no code changes or recurring tasks, providing strong protection against accidental deletions or overwrites with almost zero operational overhead. You just need to select that option. But again, since you are maintaining multiple versions, which means you will incur additional charges. A telecom company collects network usage data in real time and stores it in Aurora. They must immediately detect sudden usage drops, indicating outages with the lowest latency possible. Aurora database has a feature called activity streams, which capture real time database changes and events as they happen. By connecting a Lambda function to this stream, you can trigger detection logic instantly upon data updates, eliminating the need for periodic polling or separate streaming layers. This approach provides immediate response capability without introducing additional infrastructure like Kinesis or manual query loops. A data engineer must clean terabytes of raw data in S3 and load it into Redshift for analytics. The solution should allow analysts to run complex queries while minimizing ETL complexity and infrastructure management. We are going to use Databrew because it is a no-code data preparation tool that lets users clean and normalize data stored in S3 interactively. Once the data is ready, an AWS Glue job can automate the loading of cleaned data into Redshift, and Redshift provides a fully managed data warehouse for complex SQL analytics without the need to manage servers or custom ETL code. A VPC enabled Lambda function transfers files from an on-prem SFTP environment to S3. The function connects to SFTP successfully but times out when uploading to S3. The fix must be secure and cost effective. What are we going to do here? When a Lambda function runs in a VPC without internet access, it cannot reach public S3 endpoints. A gateway VPC endpoint provides a private secure route to S3 directly over the AWS network. So you don't need NAT gateway or internet connection. This setup eliminates timeouts and avoids extra data transfer and NAT gateway costs as well. Company reads customer data from multiple Amazon RDS databases that have inconsistent schema names and needs to identify and link duplicate or equivalent records across databases with minimal effort. How do you do? Again, using find matches. Right? We learned about this. This automatically identifies duplicate or similar records even when field names differ or values are slightly inconsistent. After using a crawler to catalog the data from multiple RDS sources, the transform can be trained and tuned directly within Glue without requiring ML expertise or external services, minimizing operational effort. A finance company runs an AWS Glue crawler on S3 data from third-party providers, but finds that the crawler creates multiple tables instead of one consolidated table. How do you handle this? Using something called this. Glue determines table creation based on data schema, its format, and folder hierarchy. If files differ in schema, format, or are stored under varying prefixes, Glue assumes they represent distinct data sets. Standardizing schema, format, compression type, and maintaining consistent prefix naming ensures the crawler groups all files into a single logical table. An application reads messages from SQS queue but sometimes goes offline. During downtime, Messages expire after 1 day and are deleted, causing data loss. How can you handle this in SQS? You need to increase the message retention period, which ensures messages remain in the queue long enough for the application to recover from the downtime. And a dead letter queue provides a secondary queue where messages that can't be processed or have expired redirected for later analysis or reprocessing. Together, these two measures ensure no messages are lost even during extended downtime. A company streams time series data via MSK and writes it to Amazon key spaces and also Amazon Open Search Service and Avro objects in S3. They need to build near real-time dashboards with minimal latency. We have something called Open Search dashboards or Open Search Service, which is optimized for near real-time analytics and search. That is what OpenSearch is about. As data is indexed into OpenSearch from the pipeline, it becomes immediately queryable by using OpenSearch dashboards with latency typically under seconds. In contrast, if you want to use Athena or S3 based solution, it will introduce delay due to batch availability and scan time. Here it doesn't. A company has petabytes of data in S3 standard spread across thousands of buckets. Data access is unpredictable. Some data sets go unused for months, but all data must remain instantly retrievable. The goal is to reduce storage costs without adding management complexity. And you already know, as soon as you see unpredictable access, what should you pick? S3 intelligent steering. This automatically monitors access patterns and moves objects between frequent and infrequent access tiers based on actual usage without performance impact or retrieval delay. Since access is unpredictable, manual lifecycle rules or tier policies are impractical. Intelligent steering eliminates manual effort and ensures immediate access from all tiers with transparent cost optimization. A media company receives millions of daily data events via Kinesis data streams and must transform and ingest them into OpenSearch service in near real time, minimizing operational management. Kinesis Data Firehouse provides a fully managed serverless delivery service that can automatically batch, transform, and load data into OpenSearch. A lightweight Lambda transformation, it allows customization of event format before indexing. Remember, I told you about this feature when we are talking about S3 object, right? Even there, it runs a lightweight Lambda and executes some transformation when reading a file. Here, same thing. Firehose handles scaling, retry logic, and delivery buffering automatically, removing the need to manage streaming consumers or ETL servers. A company stores customer data in lake formation data lake. To comply with regulations, users must not be able to view any rows for customers located in Canada. The solution must minimize ongoing administrative work. We already know the answer. With lake formation, support role-level security, allowing admins to define data filters based on column values. By creating a policy that filters out rows where country equals to Canada, lake formation enforces this restriction automatically across all query engines. For example, Athena, Redshift, Spectrum. No manual dataset duplication or user management is required, making it the lowest effort compliance solution. A company using a lakehouse architecture in Redshift wants users to authenticate to Redshift query editor using a third-party IDE like Okta or Azure AD. Redshift supports federated authentication via external IDPs using SAML 2.0. Actually, we use this at our work. We use our IAM roles which are linked to our Microsoft AD accounts. That's how we log into Redshift. To enable this, the IDP must be registered directly within Redshift. defining the SAML metadata and mapping between IDP roles and Redshift database roles. Once configured, users can log in through the IDP and access query editor seamlessly without manual credential management. A company runs a daily Spark ETL job on EMR cluster using general purpose EC2 machines. The cluster consistently reaches high CPU utilization but uses less than 30% memory, and the goal is to reduce cost. What will you do? The job is CPU bound, which means high CPU, low memory, meaning it benefits more from CPU performance than memory capacity. So, for that reason, we are going to switch it to compute optimized instances, which provide more CPU resources per dollar compared to general purpose instances, which balance memory and compute. Changing task nodes to compute optimized types lowers cost while maintaining or improving performance for CPU intensive Spark workloads. A glue job writes processed data into Redshift from S3. When rerun, the job inserts duplicate rows, and the company needs an automated way to update existing records instead of duplicating them. How can you do that using Glue? Remember, Glue writes data in batch mode, which by default appends records. By first loading data into a staging table, you can use SQL merge or update insert statements to synchronize the main table, updating existing rows and inserting new ones. This approach avoids duplicates and doesn't require an external database, which is what we do in our glue jobs. The company puts hundreds of files into Redshift fact table and wants to achieve maximum throughput by fully utilizing cluster resources during data ingestion. The copy command is optimized for parallel ingestion in Redshift. When you provide multiple S3 file paths or a folder, copy automatically distributes the load across all nodes and slices in the cluster. This approach fully leverages Redshift's parallel architecture, achieving much higher throughput than running multiple copy or insert statements sequentially. A company uses Glue ETL to transform data from multiple sources into an S3 based data lake queried by Athena. The challenge: records lack a common unique identifier, but the company must still identify and link matching entities. How is that possible? The find matches. This is what, third or fourth time we are learning this? So you already know this. A data engineer uses Glue crawler to catalog CSV files in S3 bucket that also contains JSON files. Although the crawler excludes JSON files, Athena queries still scan those JSON files, slowing performance. The engineer needs a fix that avoids affecting access to CSV files and achieves the shortest query times. Remember, Athena queries all files under a table's defined S3 path. If JSON files reside in the same prefix as CSV files, Athena will read them even if they are in part of the glue schema. Moving the JSON files into a separate folder isolates them from Athena's scan path, reducing the amount of data scanned per query and improving performance without changing access policies or crawler settings. An AWS Lambda function tries to read an object from an S3 bucket. The object is encrypted with KMS key, and the function's IAM role allows S3 access, but the read still fails. What might be causing this? S3 permissions alone aren't enough to read KMS encrypted objects. That applies with any other service, even if it is Glue or any Lambda. What you need is since this is Lambda, the Lambda execution role must also include the KMS decrypt permission for the specific KMS key used to encrypt the S3 object. Without this, the decryption step fails, causing the Lambda read operation to throw an error, even though S3 access is allowed. A data engineer must modify data quality rules across 1,000 AWS Glue data catalog tables due to new business requirements. The goal is to apply these edits with minimal operational overhead and without manually updating each table. That's where the Glue data quality comes into play, which exposes APIs that allow users to create, update, and delete data quality rule sets. By using a Lambda function, the engineer can loop through all data catalog tables and apply rule changes automatically at scale without deploying or managing servers. This serverless approach minimizes operational complexity while ensuring consistency across all tables. Two developers work on separate feature branches. Let's assume branch A and branch B derived from the master branch. Branch A has already been merged and deployed. Before merging branch B, its developer must sync with the latest changes from master to prevent merge conflicts. How do you do that? Well, using git rebase master. This reapplies the commits from branch B on top of the latest commits from the master branch. This ensures branch B is up to date with the latest production code, providing a clean commit history and avoiding merge conflicts when the pull request is created. This is like 101 when using Git. A Redshift table called employee uses a compound sort key consisting of region ID, department ID, and role ID. The company needs to determine which query pattern benefits most from this key structure. Compound sort key. In this one, Redshift stores data sorted by the first column, then the second, and so on. Queries that filter on the leading columns, which in our case is the region ID, benefit most because they enable data pruning. Redshift can skip large data blocks, which doesn't belong to the same region. Queries that start filtering on non-leading columns like department ID or role ID do not leverage the sort key efficiently as much as the region key. A company processes millions of 1 KB JSON files from S3 using Glue and loads the transformed Parquet data into Redshift. As more facilities add data, the data duration increases due to the small file problem. Too many tiny input files, which is a big concern for big data tools. Glue can automatically combine small files into larger groups before processing, significantly reducing job startup overhead and improving I/O efficiency. This approach minimizes shuffle and metadata operations and accelerates data transformation. It avoids the need for manual file aggregation or switching to another service like EMR. So what is it called? Glue Dynamic Frame File Grouping. A data engineer runs data pipelines using managed workflows for Apache Airflow. A workflow failed and the engineer must identify the cause by reviewing Airflow logs. So we are going to check the task logs in specific because these capture the output and error details of individual Airflow tasks, or you call them operators, that make up a DAG. When a workflow fails, the root cause, such as Python errors, data loading issues, connection problems, is recorded in the task logs, making them the most direct source for debugging. Other logs, like scheduler, web server, they show orchestration events but not task level execution details. A finance company uses Redshift Spectrum to query data from a shared S3 bucket containing certified third party datasets. Regulations require that no data is accessible from outside the company's AWS environment. Well, it's simple. Place Redshift in a private subnet, which ensures it's isolated from public internet access. And then enhanced VPC routing forces All Redshift traffic, including Spectrum's S3, calls through the company's VPC network rather than the public internet. Combined with Direct Connect, the company can securely access third party data sources without exposure to external networks, meeting compliance requirements. Files from multiple data sources are regularly uploaded to S3 bucket. The data engineer wants to load new files into Redshift as soon as they arrive, achieving near real-time ingestion. How can you do that? By using S3 event notifications. Each new file upload can automatically invoke a Lambda function. The Lambda can execute a Redshift copy command to load the new data immediately upon arrival. This architecture provides event-driven, near real-time ingestion without polling or scheduling jobs, minimizing latency and operational management. A technology company uses Kinesis data streams for real-time log collection and wants to ingest that data into Redshift for immediate querying and enrichment with minimal management effort. And again, we are going to use Redshift streaming ingestion, which natively integrates with Kinesis data streams and MSK to continuously ingest and query streaming data in real time without intermediate services like Firehose or Glue. The ingested data is made queryable through materialized views, allowing low latency analytics directly within Redshift. This fully managed feature removes the need to orchestrate pipelines, reducing operational overhead. An on-prem Oracle data warehouse where tables are less than 50 GB, which happen nightly refresh 1 to 2 a.m., must land as tables in S3 and stay in sync with daily incremental changes and ready for BI queries from 10 a.m. to 8 p.m. How can you do that? Of course, using DMS. This can perform an initial full load of each Oracle table to S3 and then apply ongoing CDC using the monotonically increasing column to deliver daily changes. A glue job can merge apply the CDC files to the base dataset, keeping the S3 tables current with minimal operations while avoiding daily full reloads. A new analytics team uses S3 Parquet files with Athena. Source is on-prem Oracle DB, approximately 70 tables with primary keys, where data occasionally changes. Tables must be ingested daily with the least effort. Again, same concept. We are going to use DMS natively, DMS which natively supports Oracle to S3 with Parquet output, and it can run continuous replication. First full load similar to previously, and then CDC. This minimizes custom code, handles schema table set at scale, and produces partitionable Parquet suitable for Athena. You don't need EMR or scoop or trigger lambda. Plumbing is not needed. A transportation company must reliably ingest up to 10,000 geolocation events per second, and each one being 10 bytes, into Kinesis data streams, and it wants to maximize shard throughput efficiency with minimal ops. A few minutes of delay is acceptable. We have covered one similar question. We are going to use Kinesis producer library. It batches and aggregates many small user records into a single Kinesis record, dramatically reducing per record overhead and helping stay within the 1000 records per second and 1 MB per second per shard limits. It also provides retries, time-based buffering, and asynchronous put operations, perfect for tolerating brief network issues while preserving throughput efficiency. An investment company continuously accumulates semi-structured data and needs to deduplicate, catch near duplicates, and handle common misspellings with minimal operational overhead. Stita pregnance, we have seen the same scenario again and again. Find matches, correct? Before go live, an inventory reordering system, which is a KCL consumer, reading from Kinesis data streams, received duplicate events published by an inventory management system, which is the producer. The stream scales up down automatically. And what do we remember from one of the previous scenario? Kinesis provides at least once delivery. If the KPL producer times out, it may retry puts, creating duplicates. Likewise, resharding or worker rebalancing can cause consumers to reread segments around checkpoints, surfacing duplicates. Correctness relies on downstream idempotency or dedo, example event IDs. So, these and these lead to duplicates. An e-commerce company needs hourly visibility of orders across several AWS hosted systems, each with a JDBC compliant relational database capturing the latest state. The solution should minimize custom development. Glue provides managed JDBC connectors and scheduled ETL to centralize data in Redshift with minimal code. Redshift affords scalable SQL modeling of the end-to-end order flow, and QuickSight delivers low ops dashboards that refresh hourly, meeting the operations team's tracking needs without custom applications. A data engineer needs to develop graph applications using Neptune and must choose suitable programming languages. Apache Neptune supports two major graph models, property graph and RDF graph. This is queried using SparkQL. This is queried with Gremlin. Developers can use Gremlin for graph traversal and analytics or SparkQL for semantic queries on RDF data. Other SQL-based query languages are not compatible with Neptune. So you have to use only these two. A gaming company wants to capture 20 kilobyte data records from its mobile app and stream them for 3 internal consumers, each requiring dedicated throughput and high performance per device. By sending data through Kinesis data streams using the put records API, the app can achieve high ingestion throughput. The enhanced fan out feature allows each consumer to have its own 2 megabyte per second dedicated throughput and low latency access to the same stream. This eliminates throttling between consumers and ensures optimal device throughput. The retail company uses Redshift Spectrum to query daily order data stored as CSV files in S3. With over 100 columns and 30 plus files ingested daily, users have noticed degraded query performance when aggregating daily metrics. Redshift Spectrum, it performs best when data is partitioned to limit scanned data and stored in a columnar format to read only needed columns, similar to Athena. By partitioning on order date, queries that aggregate daily orders will only scan relevant partitions. Now, changing the data to columnar format like Parquet or Arc reduces the amount of data scanned for selective queries, improving performance with minimal development effort. A company must retain customer records in S3 for 7 years without any deletions or modifications, even by the root user. Whenever they mention even by the root user, we are talking about object lock, and object lock has two modes. but we are going to go with compliance mode because this enforces immutability, which means no user, including the root account, can modify or delete objects during the retention period. This mode is designed for strict regulatory requirements and guarantees write once, read many protection. Whereas governance mode allows privileged users to bypass retention, which means root users can delete if they choose to with governance mode. So it would not meet the requirement. That's why our answer is compliance mode. A data engineer needs to create a new empty table in Athena that has this same schema as an existing table named old table. This is where we are going to use CTAS, create table as select statement. In Athena, allows creating a new table from an existing table schema and data. By adding the class with no data, Athena copies the schema only without inserting any records. This is the simplest way to create a schema replica of an existing table without data duplication. A data engineer must create a new Athena table that contains only US cities from an existing table called this. How can you do that? Well, this SQL command or whatever is shown here, it filters data from an existing table using a where class and inserts only matching rows into the target table. The insert into select syntax is valid in Athena when the destination table already exists and matches the selected schema. You might be thinking, isn't Athena used to query S3 files? Well, yes, select as well as insert, but you cannot insert um, into the same table. You are inserting into a different table by selecting from this one. So technically you are creating a file behind the scenes. Okay. Syntax, this is valid, right? When the destination table already exists and matches the selected schema. Other options like move or update are not valid SQL operations in Athena. So insert into is like if you need to have this table existing, correct? So when you do insert into, it is going to append a file to the same location. That's what basically this is doing. That's why you cannot update or move because that would require you to delete and reinsert and etc. So a company using a data mesh architecture has a central governance account managed with AWS Lake Formation. The company needs to share a new Redshift serverless data product with the marketing team, access to a subset A of columns, and also to the compliance team, access to subset B of columns. How can you do that? To grant selective column access, engineer can create views in Redshift serverless that expose only the necessary columns for each team. Then you can use Redshift data sharing to securely share these views and tables. The data share must be registered with Lake Formation to manage governance central. Lake Formation then enables controlled access and auditing within the data mesh framework. A company uses Glue for ETL and wants to ensure data quality checks run automatically during each pipeline execution with minimal implementation effort. Glue, it includes built-in evaluate data quality transform that lets engineers define and enforce data quality rules directly within Glue jobs using DL. This built-in option integrates seamlessly with Glue Studio, provides ready-to-use visualizations, and avoids the need for external libraries or custom Python code. A company runs a microservices-based application on EKS. They need to monitor logs and traces to identify points of failure in end-to-end requests, correlating cluster logs with application traces with minimal development effort. We are going to use something called Fluent Bit, which is a lightweight Kubernetes native log processor that collects logs from EKS pods and sends them to destinations such as CloudWatch, S3, or OpenSearch. And then you will use OpenTelemetry, which provides a standardized way to collect distributed traces and metrics from applications. And finally, OpenSearch service, which can store and correlate logs and traces that you got from these two, enabling deep observability and root cause analysis with minimal custom code and integration effort. A company needs to continuously stream game data from DynamoDB to OpenSearch service so that updates appear in near real time. DynamoDB streams capture item level changes like insert, update, delete in near real time. And a Lambda function can be triggered by these stream events to transform and push the data into OpenSearch, ensuring minimal latency and serverless scalability. This approach avoids batch exports or scheduled jobs, offering continuous synchronization. A data engineer is designing a physical data model in Redshift. One of the denormalized tables is growing rapidly but has no suitable column for the daily distribution key. The engineer must choose a distribution style that minimizes maintenance overhead. Well, that's why we have auto. This distribution style allows Redshift to automatically choose the optimal distribution method based on the table size and usage. For smaller tables, Redshift uses all distribution to replicate data. For faster joins. For larger tables, it switches to even distribution to balance data evenly across slices. This approach requires no manual tuning or key selection, reducing maintenance while maintaining good performance as data volume changes. A retail company needs QuickSight to calculate global currency exchange rates with 4 decimal precisions. Calculations must be pre-computed and stored in a Spice in-memory engine for fast access. Creating the calculated field at dataset level ensures the computation is performed before ingestion into Spice, which is the QuickSight's engine, meaning results are pre-computed and stored. This improves performance because calculations are not recomputed during dashboard or visual rendering. Calculations defined in analysis, visual, or dashboard are computed dynamically, leading to slower performance. So that's why you need to pre-compute it before you even bring them to BI tool. A company has 3 subsidiaries using different data warehouses: Redshift, Teradata, BigQuery. The goal is to aggregate all data into a central S3 data lake using iceberg format, performing joins and transformations with minimal operational effort. This is integration, which is the work of an ETL tool, which is the glue for us. This natively integrates with multiple data sources, including Redshift, Teradata, BigQuery via pre-built connectors. Glue can perform data extraction, transformation, and write the results directly to S3 iceberg tables with built-in merge support. This approach requires no cluster management, leverages serverless execution, and provides centralized metadata through Glue catalog. A company's EKS cluster hosts a data stream processing app that writes to DynamoDB. The containers must securely access DynamoDB without embedding AWS credentials. As soon as you see credentials, the only service that should come to your mind is Secret Manager, but that's not what we are looking here because we are talking about EKS access to DynamoDB. So we are going to use ITSA, which is nothing but IAM roles for service accounts, which enables EKS pods to assume specific IAM roles via OIDC federation eliminating the need for hard-coded credentials. The engineer attaches an IAM role to worker nodes, configures IRSA for the service account used by the pod, and grants DynamoDB permissions to that IAM role. This ensures fine-grained temporary credentials are securely provided to pods at runtime. A new data producer needs to migrate data products from on-premises data center to AWS. Company requires a secure private connection that avoids the public internet. Each pipeline also needs to maintain service account credentials securely. Okay, this is what I was talking about before. We have Direct Connect, which provides a dedicated private network connection between on-premises data centers and AWS, ensuring data never traverses the public internet. Then we have the Secret Manager, which securely stores and rotates service account credentials used by various data pipelines. This approach meets both security and compliance requirements with minimal administrative complexity. So data engineer has configured Glue data catalog for data stored in S3. They need to keep the catalog updated automatically when new files are added to the S3 bucket. Using event notifications and an SQS queue with minimal operational overhead. Again, we are going to go with event-based, an S3 event-based Glue crawler, which can automatically trigger whenever new files arrive, consuming events from SQS queue to perform incremental metadata updates. Alternatively, a Lambda function can process S3 event notifications and directly update the Glue data catalog, which is what I mentioned at my work we do. This event-driven approach eliminates the need for manual or time-based scheduling. A company uploads daily data from external sources into S3, cataloged by Glue data catalog. Sometimes the daily report runs before all data files are uploaded, and the data engineer must be notified via an SNS topic whenever data is incomplete. We already know the answer, don't we? Glue offers data quality actions that can be integrated into Glue workflow to check dataset completeness and consistency. If data fails validation, for example, missing files, null values, incomplete partitions, Glue can generate an event bridge event which is then routed to SNS for notification. This approach is serverless and fully managed, requiring minimal infrastructure setup or orchestration maintenance. The company stores PII customer data in Redshift and must provide different access levels. For the marketing team, they want full access to contact info, obfuscated claims data. Whereas for claims team, they want access to customer data only for processed claims. And finally, analytics teams, they need access only to obfuscated PII data. The goal is to implement this with minimal administration overhead. Well, luckily, Redshift supports column level masking policies, which dynamically masks or obfuscates PII fields depending on the user's database role. By creating separate roles for marketing, claims, and analytics and applying the appropriate masking policies to each, the company can enforce access rules without duplicating data or managing multiple clusters or views. This ensures secure, consistent access control directly within the Redshift engine. Financial company added new features to its mobile app, which required creating a new topic in an existing MSK cluster. A few days later, CloudWatch triggered an alarm for the root disk used metric on the MSK cluster. The root disk used CloudWatch metric indicates that broker storage is running low. When more topics or partitions are added, the MSK brokers require additional disk capacity to store messages and logs. Expanding the broker EBS volume size and configuring automatic storage scaling ensures that the brokers dynamically adjust storage as utilization grows, avoiding downtime and manual intervention. A data engineer needs to create an enterprise data catalog that indexes datasets stored in S3 and RDS, including metadata about data formats with minimal development effort. You know the answer. Use glue crawlers, which scan data automatically in different sources like S3 and RDS databases, identify schema and data formats. The company uses Data Brew to detect PII data in its data lake for quarterly inventory assessments. The privacy policy includes custom PII categories that are not covered by Data Brew's standard data quality rules. The data engineer must scan for these custom categories across multiple datasets with minimal operational overhead. How can they do that? Data Brew allows users to define custom data quality rules in addition to its built-in checks. The data engineer can define custom rejects patterns or logical rules that match organization specific PII categories, then apply these reusable rule sets across multiple data sets. This avoids manual review or external scripting, leveraging Databrew's serverless automation for minimal maintenance. The company receives a daily data file in S3, which is cleaned and transformed by an ETL pipeline into an output file. If the input file is empty or missing required field values, the company must retain the previous day's file instead of overwriting it. How do you do that? Glue data quality, it provides a built-in, what did we say? Built-in evaluate data quality transform, allowing engineers to define rules in DQDL, data quality definition language. These rules can check for non-empty files, non-null fields, or other data integrity constraints. Glue can halt processing and prevent overwriting the previous day's file, all without external orchestration. A marketing company stores data in S3 with versioning enabled on some buckets. To optimize storage costs, the company needs to identify incomplete multi-part uploads and outdated object versions across multiple S3 buckets. You have a feature in S3 which is called storage lenses, which provides organization-wide visibility into S3 usage and activity metrics, including incomplete multi-part uploads, object versions, and storage class distribution. It automatically collects and aggregates metrics without manual scripting or query. Compared to S3 inventory or CLI reports, Storage Lens offers interactive dashboards and automated reports with zero maintenance effort. A gaming company streams clickstream data via Kinesis data streams, then Firehose, then to S3 in JSON format. Data scientists query this data with Athena, but costs are rising due to the large number of small JSON files. The company wants to reduce query costs without rebuilding the data pipeline. By configuring data Firehose to deliver data in Parquet format, the company drastically reduces Athena query scan costs and improves performance. Firehose automatically batches and compresses data into larger Parquet files. For previously stored JSON data, a Glue ETL job can combine small files and convert them to Parquet, maintaining your prefix of year MMDT for optimized partitioning. Finally, you update the Athena table with alter table add partition, which ensures queries can access the transformed data efficiently. A company needs to manage costs and table size for DynamoDB table without disrupting ongoing operations. The solution must automatically delete data older than 1 month and require minimal maintenance. Anytime, if you want to delete data based on time, remember there is a feature in DynamoDB which is called TTL. This allows you to define an attribute, like which means just a column that specifies when each item should be deleted. Awesome, right? Items automatically expire after the defined timestamp is reached, freeing up storage and reducing costs without affecting read-write availability. This is a fully managed serverless feature that requires no manual intervention or Lambda orchestration. All right, it's our time to take a break again, and I hope this is our last break. And after this, we will race to the end. See you in a couple of minutes. All right, here we are. Let's continue with our journey. A company has an S3 bucket in a hub account with KMS encrypted data and a QuickSight instance in another account for visualization. The goal is to enable cross-account access so QuickSight can read from S3 bucket securely. I think we have already seen similar scenario. How do you do that? Well, for cross-account access to KMS encrypted S3 objects, the QuickSight's service role in BI account must have permissions to use the KMS key. You provide that in the key policy as well as the IAM policy. And the BI account, the service account, the QuickSight service role in BI account must include the KMS key as a resource in its access policy. This setup ensures QuickSight can decrypt S3 objects when loading data without requiring bucket sharing via AWS RAM or anything like that. This is the de facto cross-account access related question. A car sales company receives daily compressed files, approximately let's say 5 KB, containing new car listings uploaded to S3. The company wants to see updated listings immediately after upload and automate data processing workflows and allow for one-time queries and analytics. The solution must be scalable and cost effective. When vendors upload data to S3, S3 event notifications trigger Lambda function which starts a glue job to process the new listing data automatically. The transformed data remains in S3 and can be queried using Athena for ad hoc analysis or visualized via QuickSight dashboards. This fully serverless approach eliminates the need for EMR or provisioned infrastructure, ensuring low cost and minimal operational overhead. You are seeing this, right? Pretty much most of the questions or scenarios that we covered so far, they all have similar architecture. You have events, then you trigger Lambda, that triggers a glue job, or you have events, then through event bridge you trigger Lambda or glue. Once you learn or get into this, it's very easy for you to understand different architectures. A company operates in multiple AWS regions, each with its own EFS file system. The data science team operates in a single region and their data must remain there. A data engineer must create a single data set by processing files from all EFS systems using step functions and Lambda with least operational effort. How can he handle that? Using data sync, which simplifies cross-region data movement between EFS to EFS file systems with automatic scheduling, encrypting, and parallel transfer optimization. Once data from other regions is synchronized into the EFS in the data science region, Lambda functions can mount and process it locally. This ensures compliance with data residency, minimizes custom orchestration, and it doesn't require any VPC peering or manual replication setup. A company runs its applications on EC2 instances and must ensure secure SSL TLS encrypted communication with AWS managed infrastructure. The data engineer needs a solution to simplify certificate generation, distribution, and rotation with automatic renewal and deployment and minimal operational overhead. Anytime you see in any AWS exam regarding certificate management and etc., there is only one tool that can
actually do on AWS, which is ACM, AWS Certificate Manager. This provides fully managed SSL TLS certificate management, including automatic renewal, rotation, and deployment to supported AWS resources like EC2, load balancers, CloudFront, and API Gateway. It removes the need to manually create, upload, or renew certificates, ensuring secure data in transit communication with virtually no maintenance burden whatsoever. A company stores customer data in S3 using SSC KMS encryption. The data includes PII, data like social security numbers, account details, Aadhaar number, passport number, etc. that must be masked before analysis, while allowing authorized users secure access during pre-processing. The solution must be low maintenance and ensure data security throughout the pipeline. So how are we going to handle it? Using Data Brew. This provides no-code interface for defining data transformations and masking PII fields before analysis. It integrates natively with S3 and can automate ETL jobs that clean and obfuscate sensitive data. Meanwhile, AWS IAM enforces fine-grained access control to ensure that only authorized users can view or process raw PII during the pre-processing phase. Together, these services provide a secure and automated way to manage and protect sensitive data end to end. A data engineer is launching an EMR cluster that loads data from S3 bucket. The data in S3 is already encrypted using an AWS KMS key, and the engineer must ensure that data is encrypted both at rest and in transit when processed by EMR. A PEM file path in S3 is provided for secure in-transit communication. How would you handle this? Amazon EMR security configurations, they let you centrally define encryption settings for data at rest using KMS managed keys for S3, EBS, and local disk. And for in-transit via TLS SSL certificates referenced from a PEM file. By specifying both the KMS key and PEM file path in a single configuration and applying it during cluster creation, all communication and storage within EMR remain secure without additional manual steps. A retail company uses Redshift for real-time inventory management and has a SageMaker real-time endpoint for machine learning predictions. The company needs to make real-time recommendations and predict future inventory needs from within Redshift. For this, we are going to use Redshift ML, which allows users to create and train ML models directly in Redshift, or use existing SageMaker models for real-time predictions without exporting your data. By using SQL functions, Redshift can invoke a remote SageMaker endpoint for real-time inference, enabling continuous low latency insights into inventory levels and predictive forecasting, all from within Redshift. A company stores CSV files in S3 bucket, and the data engineer needs to rename a column, remove specific columns, ignore the second row, create a new column based on the first row, then filter rows by a numeric column value. The process data should be stored in a new S3 bucket with minimal development effort. So as you can see, what are you doing here? You are doing transformation. So for that, what would you recommend? We would recommend Glue, and in specific, we would recommend Data Brew, because it's a no-code interface for data transformation tasks like everything that's listed: column renaming, filtering, conditional creation of new columns. It supports automation through recipes, which can be applied to all CSV files in an S3 location. This allows data engineers to apply the required transformations quickly without writing Python or Spark code, while automatically saving results to the target S3 bucket. A company uses Redshift with data encoding already applied to tables. the data engineer discovers that some tables use suboptimal compression encoding, leading to inefficient storage and slower queries. The goal is to determine and apply better compression encoding. Well, since it's Redshift, the analyze compression command in Redshift evaluates existing column compression encodings and recommends optimal encodings for better performance and reduced storage. A data engineer can then manually apply the suggested encodings by recreating the tables or altering columns. This is the standard and most accurate way to assess and improve compression in Redshift. A company stores customer records in S3. Records must be immediately accessible for the first 30 days, but are rarely accessed afterward. The company must minimize storage costs while maintaining compliance and data availability. We would need here an S3 lifecycle policy which can automatically transition objects from S3 standard for the frequent use to S3 standard infrequent access after 30 days. This ensures that new records remain instantly available during the regulatory 30-day period and that older records move to a lower cost storage tier without affecting availability. It is the most cost-effective and low maintenance approach for this access pattern. A data engineer is building a quick site dashboard showing company revenue across multiple AWS regions. The dashboard must always display the total revenues for a region, even when users drill down into finer levels of the data hierarchy. Okay, this is more of a reporting question. We are going to use something called level aware calculations. This you do in QuickSight, which allows you to aggregate metrics at a fixed level. In our case, the region, regardless of the visualization's drill down or grouping context. By using an LACA like sum over, there is a function called sum over. The data engineer ensures that the total revenue per region remains constant across all levels of analysis. A retail company stores customer data in S3, some of which includes PII. Before sharing datasets with business partners, the company must automatically detect and exclude PII data, minimizing manual checks. And you might be thinking of using glue, transform, etc. But again, we are talking about only S3, and in S3 we have a feature called Macy. Amazon Macy provides automated sensitive data discovery that scans S3 objects to detect PII and other sensitive information like names, SSNs, and financial data. Once enabled, Macy continuously monitors new and existing S3 objects with minimal configuration, generating findings that identify datasets containing PII. This removes the need for custom scripts or manual SQL-based inspection. A data engineer must create an empty duplicate table in Athena for data processing tasks. The existing table contains 1000 records, but the new table must have only the same schema, no data. I hope you remember this similar question. We are going to use CTAS, create table as select statement in Athena allows creating a new table based on the schema of an existing table. By including with no data clause, Athena copies only the schema definition and skips inserting data rows, resulting in a structure only table, which is ideal for staging or testing. A company stores CloudTrail logs in a data lake on S3, cataloged via glue and partitioned by year. Recently, Athena queries on one of the tables returned no data. The engineer must identify and resolve the issue. How would you do that? Athena queries can fail to return results for multiple reasons. One of them being the table location points to an incorrect or outdated S3 path. So you verify that. or new partitions were added to S3 but they are not registered in the glue catalog. Remember this situation that I explained? So what do? You can manually add partitions, or you can just simply run msck repair table, which refreshes Athena's partition metadata, allowing newly added S3 partitions to be recognized without recreating the table. This combination ensures Athena queries access the correct data. We have faced similar issues several times. What used to happen is the S3 events we used to get from other team, and whenever we get that event notification, they send it, they put it in their SNS, and our SQS is subscribed to their SNS. So when we get the notification from SNS into our SQS, then our Lambda gets triggered. But what used to happen is sometimes whenever they send the notifications, our SQS never received them, which means our table never repaired or added the new partitions. So we were querying the data table, but we are not getting any new data, and our production jobs they ran with dry runs, didn't load any data. And then from our business users, after a couple of days or months, sometimes they come back and say like, you know what, we are missing this particular day's XYZ data, can you check it? And then we have to go back and debug and see, oh, on that day we didn't receive any notifications, so we didn't receive any source data, which means we didn't put any of the data we are missing. So it's a headache. So you need to build things that you actually check. So what we did later on was we added a step every day after we extract the data from the source, checking like, did we receive any data today or not? We check the count. If the count is 0, then we will send an email to our team to check, is it actually no data or did we miss it? So that way you will make sure that there is something wrong, and then you will go and fix it instead of users coming back to us after months, which is very bad. A data engineer must orchestrate ETL workflows that includes running Apache Spark jobs on EMR, making API calls to Salesforce, loading data into Redshift. The workflow should handle retries and failures automatically and must be written in Python. So this particular part actually gives away the answer as MWAA, because the other options are what? glue workflows, and you cannot use the Salesforce thing in there. So the other option is step function, and step function is not written in Python. Okay. So our answer is MWAA, which is a managed Apache Airflow service that allows users to define ETL workflows in Python. Airflow natively supports task dependencies, retries, failure handling, and parallelism, and integrates with multiple AWS services as well as external APIs like Salesforce. Using Airflow eliminates infrastructure setup and ensures scalable, fault-tolerant orchestration of complex pipelines. Oops, I guess I haven't showed you all this. My bad. A data engineer maintains custom Python scripts used by multiple Lambda functions for data formatting. Currently, when a script changes, the engineer must manually update each Lambda function, leading to high maintenance effort. So a scalable solution is needed to simplify this update process. I think we have discussed this scenario as well, and I explained you what I do at my work, right? So we have multiple projects that connect to different databases. So in each project, you don't have to import the libraries. For example, let's say if you are connecting to SQL Server, you don't have to import the SQL Server libraries into your Lambda. Instead, what do? We create layers, Lambda layers, which allow you to package shared libraries like Python scripts, libraries, or configuration files separately from the function code. When an update is required, the engineer updates the layer version, and all the Lambda functions using that layer automatically get access to the newer version once redeployed. This reduces duplication and ensures consistency across functions. And the major advantage is when you have to upgrade that particular shared code, you don't have to do it in each Lambda function. That's the awesome part of this. A company stores customer data in S3 and multiple teams need access for analytics. The company must ensure that PII is not accessible to any of these teams while keeping operations simple. Again, the same questions. S3 plus PII equals to Macy. A company stores process data in S3 and enforces a strict data access policy using IAM roles for team-based permissions. The company wants to receive notifications when a user violates access policies, and each alert must include the username responsible for the violation. So the goal is you need to get which user actually did that. So that kind of data can only be possible with CloudTrail because it captures all API activity that happens on your account. That includes S3 object level API activity as well. For example, get object, put object, delete object, and logs details such as user identity, source IP, and timestamp. By forwarding these events to CloudWatch, the company can set up CloudWatch alarms to notify admins when unauthorized access attempts occur. This approach ensures visibility, traceability, and automation with minimal manual configuration. A company receives customer data from a third party that includes a field containing JSON values. The data must be loaded into an existing Redshift data warehouse, which already stores order and product data. The goal is to ingest the JSON field with minimal development effort. Well, that's not a big problem if you ask me, because there is something called super data type in Redshift, which supports semi-structured data like JSON, Parquet, and Avro. It allows ingestion of nested JSON data without requiring pre-processing or flattening. Once loaded, Redshift's partition by and variant functions using Redshift Spectrum or PartiQL, they can query and transform the JSON data efficiently for analysis. This avoids the complexity of external ETL pipelines and etc. A company stores daily sales records, 2 GB, approximately 2 GB per day, in MySQL database, and maintains 100 GB of sales opportunities in Salesforce. The data engineer must develop a nightly process to analyze and correlate both data sets with minimal operational overhead. Do you remember, if you have to integrate a third party SaaS tool, what is the AWS service you need to use? AppFlow. This provides a fully managed no-code integration with Salesforce, automatically fetching data securely into AWS. Then AWS Glue can connect to MySQL database and extract daily records into a common format, let's say Parquet. The correlation logic can be handled within Glue jobs, and step functions orchestrate the workflow to ensure the jobs runs nightly with proper sequencing and monitoring. This eliminates the need to manage Airflow clusters or writing custom pipelines. A company stores server logs in S3 and must retain them for 1 year. After that period, logs must be automatically deleted with the least maintenance effort. Simple. You will use S3 lifecycle policies or rules, which can automatically manage object expiration. By defining a rule to expire objects 365 days after creation, S3 will permanently delete all logs without any manual intervention or code. A company is designing a serverless data processing workflow in step functions. The workflow involves ingesting data from external API, transforming it with multiple Lambda functions, loading results into DynamoDB. The workflow must perform specific steps based on the content of the incoming data. How can you do that? Since they already mentioned step functions, we will use something called choice state. What did we learn in these videos? We learned about state map. We learned about parallel map. I think it's called parallel state. Now there is something called choice state. This allows conditional branching within a step function workflow. So how it is like it's just a state in the step functions where you can enter and or filters based on the data that it gets. So it just uses these filters, and let's assume that is rule 1, rule 2. So if your first rule becomes true, then you will say go here. If second rule becomes, go here. So if you only have one rule, then you can have this to default. So the second one, all default, whichever condition this didn't match, then it will go into this one. So it's a conditional, you can say that. It evaluates input data against defined conditions, for example, field values or comparison expressions, and routes execution to different branches accordingly. This enables dynamic decision making based on data content, eliminating the need for hard-coded logic within Lambda functions. A data engineer created a table named CloudTrails_logs in Athena to query CloudTrail logs. They need to list error events, error code not null, that occurred since Jan 1st, 2024 and return the 10 most recent errors. How can you do that? Well, to fetch only error events, the query must include a where error code is not null condition. The event time filter ensures only logs from 2024 onward are included, and using limit 10 restricts the result set to 10 most recent error entries. So the selected fields, event name, error code, and error message, they provide relevant error insights without unnecessary aggregation. An online retailer receives order summaries from multiple delivery partners which are stored in S3. Some summaries contain PII about customers. Data engineer must automatically detect PII in these summaries to enable redaction with minimal operational overhead. You already know it. S3 plate PII equals to Macy. A company's Redshift data warehouse is accessed daily by hundreds of users via different IAM roles. The company must control user access to data based on job role, permission level, and data sensitivity. That's why we will use RBAC. In Redshift, simplifies access management by granting privileges through roles, role-based access control. You can see that here. Rather than managing permissions for individual users, roles can represent job functions and control access to schemas, tables, and other objects according to organizational policies. Users inherit privileges through assigned roles, ensuring centralized and scalable permission management. A company uses data zone for data governance and a business catalog. Their data lake resides in S3 and they use Glue with the Glue data catalog. The data engineer must publish Glue data quality scores to the Amazon Data Zone portal. How can they do that? AWS Glue data quality, it uses DQDL to define validation rules for data sets stored in the Glue data catalog. These rule sets can be scheduled for recurring evaluation. By configuring data zone with Glue as a data source and enabling its data quality configuration, the results of Glue's data quality evaluations, for example like scores, pass fail status, etc., are automatically pushed to the data zone portal, allowing stakeholders to monitor data health centrally. A company needs to comply with security requirements by logging and storing all user activities and connection details from their Redshift data warehouse. Well, Redshift provides an option to enable audit logging, which records both user activities like queries, connections, and authentication attempts, as well as connection details. These logs can be automatically delivered to an S3 bucket for long-term retention, auditing, and analysis. S3 storage ensures durability, scalability, and easy integration with monitoring and analytic tools such as Athena or CloudWatch logs as well. A company wants to migrate its data warehouse from Teradata to Redshift while minimizing operational effort. Okay, so what are we doing? We are converting from one vendor to another vendor. So you need the schema will be different between these. So in order to handle that, you will use something called AWS SCT, schema conversion tool, which automates the process of converting Teradata schema, views and stored procedures into compatible Redshift syntax. Once the schema is converted and deployed to Redshift, then we are going to use DMS, our old friend, which can handle the continuous or full data migration, replicating data with minimal downtime. This combination offers a managed and automated migration workflow requiring minimal manual intervention. A company wants to consolidate multiple AWS and third-party data sources into a central data warehouse for fast analytics using Amazon QuickSight in the directory query mode. Query usage spikes unpredictably and occurs only during a few hours each day. We will use Redshift serverless for this because it automatically scales compute capacity based on the workload demand, removing the need to manage clusters manually. It integrates seamlessly with QuickSight Direct Query, enabling low latency analytics while only charging for the actual compute used during query bursts. Storing data in Redshift managed storage like RMS ensures performance, durability and automatic operation or optimization without ongoing maintenance. A data engineer is using Amazon Kinesis data streams to process user behavior data. Some shards receive a disproportionate amount of data, leading to throttling issues due to hot shards. Throttling in Kinesis often occurs when one or more shards, like hot shards, receive more data than their write or read throughput allows. By increasing the shard count, you improve overall stream capacity. The data producer must then use a partition key strategy to distribute records more evenly across shards, ensuring balanced load and avoiding throttling. A company's multi-step data pipeline built with S3 Lambda step functions needs real-time alerts when any pipeline step succeeds or fails. Well, that's possible. Step functions, it emits execution status change events. For example, whether the execution succeeded or failed to event bridge. By creating an event bridge role to capture these events and trigger an SNS topic, you can automatically send alerts to email, SMS or monitoring systems. This setup provides centralized and real-time visibility into pipeline health without modifying existing Lambda or S3 logic. You can do this for Glue, Lambda or any other service as well, because pretty much Event Bridge gets notifications from pretty much all these services. A company's application uses API gateway with Lambda with DynamoDB. The API's Lambda function experiences high latency because it's throttled when other Lambda functions in the same account see increased invocations. The company wants to isolate the API's Lambda function so it isn't affected by others, and you need to implement this with cost effectively. So what can you do? By assigning reserved concurrency. So you have two things, provisioned and reserved. Provisioned concurrency means you will have ready to be run Lambda functions, whereas reserved concurrency guarantees a fixed number of concurrent executions that are dedicated exclusively to that function. This ensures that other Lambda functions cannot consume its concurrency limit, preventing throttling due to shared resource contention. Unlike provisioned concurrency, which I just mentioned, which pre-warms instances, reserved concurrency only isolates capacity, making it more cost effective for this scenario. A company needs to make a JSON file containing PII and non-PII available for analytics. Non-PII data should be accessible to everyone, while PII data should be restricted to specific users, all with minimal operational As soon as you see specific users, you know the answer. It's lake formation, because this is the only one that gives you that fine-grained row column level access. A company uses KMS to encrypt its Redshift cluster and wants to enable cross-region snapshots as part of its disaster recovery plan. The data engineer must configure this using the AWS CLI. Can he? Of course. When using KMS encrypted Redshift clusters, cross-region snapshot copying requires explicit authorization for the destination region's KMS key. You must first create a snapshot copy grant in the destination region to allow Redshift to use that key. Then enable snapshot copy in the source region and reference that grant. This ensures that snapshots are automatically encrypted with the destination region's KMS key and replicated securely for DR purposes. Otherwise, if they are encrypted with the source region, then in the destination region you won't be able to unencrypt them. That's why while creating the snapshot copy itself, you are using the destination region's key. A company is building a data lake on S3 and must replicate existing and future changes from multiple source databases, most on RDS and one on-premises SQL Server Enterprise, into Parquet format cost effectively. What are we going to use? DMS, which supports full load as well as change data capture to continuously replicate new changes from heterogeneous sources like RDS and on-premises SQL Server into S3 targets. DMS can output directly to S3 in Parquet format. A company ingests daily retail order data into S3. A data engineer runs weekly queries across multiple date ranges and needs to ensure performance remains efficient as data volume grows, all while keeping costs low. Do you remember how you can do that? You already guessed it, using partitioning. By partitioning S3 data based on the order date column like year, month, day, Athena can prune unnecessary partitions, scanning only relevant subsets of data. A data engineer has two data sets, primary and reference, each containing city and state columns. They need to ensure that the values in primary exactly match corresponding values in reference using data quality with DQDL rules. How can you do that? Well, there is something called referential integrity rule in DQDL, which validates that all records in the primary dataset have matching keys in the reference dataset, similar to enforcing a foreign key constraint that you would do in an RDBMS. A match ratio of 1.0 indicates a perfect match between both datasets, meaning every city-state combination in primary exists in reference. This rule ensures complete referential consistency across data sources, because in data lakes and S3 you don't have that primary foreign key, right? So this is one way to check that. A company has an on-premises PostgreSQL database that is frequently updated. It must migrate this data to Redshift over a VPN connection and ensure near real-time synchronization. How can you do that? Well, DMS supports two main migration phases, right? One is full load, another one is CDC. By enabling CDC, Redshift stays nearly synchronized with PostgreSQL source, ensuring minimal latency for ongoing updates. This approach avoids manual backups or batch uploads, offering a managed low latency fault tolerance migration process. A company has new datasets in CSV and JSON formats. Data engineer must make them queryable with SQL for data analysis while keeping costs minimal. Say the pregnancy, we learned this million times so far. You are going to use Athena with a combination of Glue. Both are serverless. Why this? Well, Glue, you are going to use Glue crawlers automatically infer the schema and register the tables in Glue data catalog, making their data accessible to Athena, which uses standard SQL to query directly from S3. A retail company stores billions of order records in Aurora table and needs near real-time operational reporting that joins orders with a campaigns table in Redshift. So you are joining between two different databases. How can you do that? Well, Aurora has this feature called zero ETL integration. This provides near real-time replication of transactional data from Aurora to Redshift without building or managing ETL pipelines. It automatically streams changes from Aurora to Redshift managed storage, allowing analytics to run on up-to-date data with minimal latency. Creating a materialized view in Redshift enables efficient joins with the campaigns table for marketing analysis, all while keeping the Aurora workload isolated. This is kind of similar to integrating streaming data into Redshift. A company stores CSV files which are almost 5 MB in S3 and needs an automated pipeline that loads data into Redshift using Lambda function. The pipeline should trigger automatically when new files arrive. This is our textbook example, isn't it? You will integrate S3. You can integrate with EventBridge if you want, or you can just use Lambda triggers as well. In this case, let's integrate S3 with EventBridge, which can react instantly to file uploads without manually polling. EventBridge provides fine-grained event filtering and reliability over direct S3 Lambda triggers. So that is there as well. When a new object is created, the EventBridge rule triggers the Lambda, which runs the copy operation into Redshift. This approach is fully serverless, cost-effective, and requires minimal configuration. A company stores sensitive data in Redshift table and needs to control access based on user roles without duplicating data. So the customer support, they can view only the last 4 characters. Audit users can view the full name or full value. Other users cannot access the data. I think we have seen a similar example previously. By using dynamic data masking, we can do this. A data engineer uses CloudFormation to manage access to data stored in S3. When running a glue crawler on some path, the execution fails with an error saying location is not registered. What does that mean? Well, when CloudFormation governs an S3 bucket or path, only registered locations are discoverable and accessible to glue crawlers and jobs. Registering the path mentioned in the scenario in CloudFormation assigns it a data location resource, allowing the crawler's IAM role to access it under CloudFormation permissions. Without registration, even valid IAM permissions won't allow access, resulting in this specific error. A company has built a data lake and data warehouse on AWS and wants to implement a data catalog that allows users to add business metadata and glossary terms for each asset with minimal operational overhead. We discussed about a service, didn't we? Which is the data zone. This provides an integrated data cataloging and governance platform that supports business metadata, glossary management, data discovery across multiple AWS and external sources. It enables organizations to manage both technical metadata like schemas and lineage and business metadata like descriptions, classifications without custom development. Data Zone's data portal allows users to easily explore assets, apply glossary terms, and control access, all without needing to manage infrastructure or build separate web applications. A data engineer is using Glue ETL job to clean up outdated records in the accounts table by removing customers found in monthly accounts update. How do you handle this? In Glue 4.0 and above, it supports Apache Spark 3. So the merge statement supports delete operations when using the when matched then delete clause. This command removes all records in the target table that have matching keys in the source table. It's a valid and efficient way to perform data cleanup or synchronization operations within Glue SQL ETL jobs. A company receives CSV files, they are about 100 to 300 KB from a marketing vendor every 40 to 60 minutes into S3 bucket. The data engineer needs to automatically load each file into Redshift with minimal management. Well, that's easy for us. Event bridge listens to S3 object created events and triggers Lambda, which connects to Redshift and executes a copy command to load data from S3 directly. Since Lambda is event driven and serverless, it scales automatically. You know this architecture already. Company maintains 1 TB dimension table in S3 with 10 million records. Each day, 10,000 records need to be updated in the base table. The solution must ensure fast updates and low runtime. You have a solution called Apache Hudi, which enables upsets and incremental data processing on S3 based datasets. Remember we spoke about the Athena, how you can insert, but you cannot perform updates for data that exists in S3. Well, here you go, Hudi. Hudi can do that. It tracks changes efficiently using metadata and versioning, avoiding full rewrites of large datasets. Running this on EMR with Spark provides distributed compute power and the ability to perform fast updates or merges on only the changed records, drastically reducing processing time compared to full reloads. A data engineer's glue Apache Spark ETL job fails with an error, saying no space left on device. The engineer must identify the root cause and resolve it. The error usually occurs when Spark executors run out of local disk space due to heavy shuffling or data skew, where some partitions hold significantly more data than others. The Spark UI and glue metrics help pinpoint skewed partitions and stages, and enabling write shuffle files to S3 offloads intermediate shuffle data to S3, avoiding local disk exhaustion. And then there is something called salting technique. It just adds random keys, redistributes skewed data evenly across partitions. This combination mitigates skew efficiently without scaling infrastructure. A company's AWS Glue jobs, which are in a private subnet, can no longer connect to RDS instance after a security group modification. The security group now only allows inbound SSH traffic from one IP. The company must restore the connectivity. For glue jobs and RDS to communicate within the same security group, the group must have an inbound rule referencing itself as the source. This allows intra-group communication over necessary ports such as 3306 for MySQL or 5432 for Postgre. Limiting the group to only SSH inbound traffic blocks database connectivity. Adding the self-referencing TCP rule restores secure internal communication without exposing the database externally. A company's new data pipeline occasionally produces missing data in business intelligence reports. The data engineer must add data quality checks to detect null values and ensure referential integrity before storing the data. We already seen both the scenarios, didn't we? We are going to use Glue's DQDL for defining and enforcing quality rules directly inside ETL jobs. For the isComplete rule, it validates that key columns are not null. And then we have the referential integrity rule, which checks that relationships between data sets like foreign key constants hold true. A company is setting up a data pipeline to extract client data from S3, perform quality checks and transformations, then store processed results in relational database for future queries. Well, it's a no-brainer. We are going to use Glue ETL with combination of data quality. Right? The Glue data quality to automatically suggest and evaluate rules. This eliminates the need for separate tools like Databrew and etc. A company stores vendor-related data in Redshift. Vendor requests that their data be transferred weekly into their S3 bucket. Company must automate this export process. This is the easiest question, right? you will use unload if you want to unload data from Redshift. This efficiently exports query results or tables into S3 in parallel using multi-Redshift nodes for performance. And you might be thinking, why do you need Glue? Well, this natively integrates with Redshift and can orchestrate this process on a scheduled basis without maintaining additional infrastructure. Company uses shared Redshift cluster for 2 departments. Each department must have unique access permissions to its own tables and views, but cross-department queries must still work. We already know Redshift supports schema-based access control, allowing admins to grant or revoke privileges on an entire schema instead of individual tables or view. This design maintains logical separation between departments, simplifies permission management, and still allows cross-schema joins within the same database. Managing access at the schema level reduces the need for complex user or table level permission updates. A company needs to ingest streaming data from MSK or Kafka cluster into Redshift. The solution must ensure low data access latency. How do you do that? By leveraging Glue streaming ETL job to process data from MSK, load it into S3, and then query it from Redshift Spectrum. It's as simple as that. A sales company uses Glue to process 44,000 small hourly files, which are about 200 to 300 KB each, stored in S3 when running a Glue pipeline on historical data. Performance is very poor even with the smallest worker type. How do you improve it? We discussed about this scenario as well. When you have too many small files, which causes significant overhead due to metadata operations and I/O inefficiency. So the dynamic frame grouping option in Glue merges small files into larger partitions before processing, reducing the number of read-write operations and improving Spark parallelization. This approach boosts performance without needing more or larger workers. A company wants to combine and analyze data from multiple SaaS applications using QuickSight. The data engineer must extract the data and make it queryable for QuickSight dashboards. Stitha Pragnans, as soon as you see SaaS integration, what should be the service that come to mind? App-Flow. A company runs several AWS applications that generate logs. The team wants to query and visualize logs in near real time with minimal delay for insights. As soon as you see logs and real time, only one service should come to your mind, which is OpenSearch. CloudWatch logs can stream log data continuously to OpenSearch service using subscription filters. OpenSearch provides the real-time search and analytics engine ideal for log aggregation, monitoring, and visualization. An e-commerce company uses AWS Glue ETL to collect and clean millions of daily orders, storing the output as CSV files in S3 standard. Analysts run daily queries on this dataset. The company wants to reduce storage and retrieval costs without affecting performance. Stitha Pragnans, you already know CSV files. Performance is worst, we already know that. And too much storage. So instead you will use Parquet. A data engineer uses Athena notebooks with Apache Spark to query partitioned S3 data. A Glue crawler updates partitions automatically. Engineer needs to minimize data scanned to improve query efficiency and reduce costs. Well, when querying partition data in Athena Spark, partition pruning occurs only if filters explicitly reference your partition keys. This allows Athena to skip non-relevant partitions, scanning only the subset of data needed for the query. Even if partitions are up to date in Glue catalog, failing to apply filters results in full data scans, increasing query time and cost. A company's Redshift cluster runs in public subnet inside a custom VPC. QuickSight Enterprise Edition instance is in another AWS account in a different VPC. The company must allow QuickSight to query the Redshift cluster to refresh dashboards while maintaining security. For QuickSight to connect to Redshift, Redshift's cluster security group must explicitly allow inbound access from QuickSight's resources. Opening the Redshift port, which is the 5439, to the QuickSight security group allows secure direct communication between both services. You don't need to set up complex peering or endpoints, since both subnets are public and ACLs already allow traffic. A data pipeline processes a large daily file uploaded to S3 at unpredictable times. The AWS Glue workflow uses hundreds of workers and must start processing immediately upon file arrival to minimize latency. How can you handle this? Well, S3 does not directly integrate with Glue triggers, but by enabling S3 data event logging in CloudTrail, every put object action becomes an event that can be captured by Event Bridge. An Event Bridge rule can then invoke the Glue trigger automatically to start the workflow. This event-driven approach ensures the pipeline runs as soon as the file arrives without polling or scheduling overhead. A data engineer must automatically run a short transformation job, which is less than 1 minute, whenever a new file is added to S3 bucket. The result must be emailed to data engineer. About 1 file is uploaded every hour, so the solution must be lightweight. As soon as they said less than 1 minute, you already know the solution. You will use Lambda. S3 Lambda SNS, simple setup. A data lake in S3 stores customer contact data cataloged by Glue. The PySpark Glue jobs fail because the postal code column contains invalid or inconsistent values like extra digits, special characters, etc. The data engineer must clean or validate postal codes during processing. How can you do that? By explicitly defining PySpark schema, the Glue job can control data types, enforce valid formats, and reject or coerce invalid postal codes before transformation. This avoids downstream errors caused by schema inference, mismatches, or corrupted data. An AWS Glue workflow occasionally fails due to data quality issues, and the business reporting team must receive email alerts whenever the flow fails. How can you do that? We already discussed about this. You will have Event Bridge, which captures Glue jobs state change events like succeeded, failed, and forwards that to SNS. A company runs multiple critical Glue data pipelines and needs a monitoring mechanism to alert stakeholders automatically if any pipeline fails with minimal. We just discussed about it, didn't we? Again, you are going to use Event Bridge, which can track all Glue job lifecycle events. But we are also going to use CloudWatch. Why? Because by routing failure events to CloudWatch metrics, you can trigger CloudWatch alarms when thresholds, like instead of every failure, if the failure count increases greater than 5 or 10, you can send the you can trigger the alarm which notifies the stakeholders via SNS. So this integration creates a fully managed event to metric to alert flow with no manual log parsing. That's all from my side for this particular exam. If you haven't liked, commented, or subscribed to this channel, please do that so that I can do or upload more exam study guides like this one for other exams as well. I will only do that if you like, comment, and subscribe. So please do that, and I hope you enjoyed this video. If you did, go ahead and do that as well. That being said, thank you very much for your patience. It's a long video. Watch it multiple times. make notes using pen and paper, and do check out other playlists like the projects playlist and the Spark masterclass playlist if you want to upskill yourself. I am glad I am part of your upskilling process. So see you in some other playlist. Have a great day. All the best for your exam. See you in the next video. Love you all and peace out.